proceed ahead. On this dais, let me have to introduce my project coordinator of this regional science center, Bhubaneswar, Sri Kapil Jain sir, and along with that one, in collaboration with whom that all the time that we want to popularize our science from time to time, and she is none other than Srimati Pralita Mishra ma'am, Assistant Director from Director of Team SAT, and the family members of our Regional Science Center Bhubaneswar, and also the team from our SCA team. So we welcome you again in our state level science seminar 2025 on this topic. Without time taking, so let me have to give a short brief about the welcome address of our today's state level science seminar. So I would like to request Sri Kapil Jain sir have a few words along with all the 30 districts. And this is the fortunate enough that from the 2 to 3 years that all the 30 districts have been present with a short duration of the time. So thank you all for joining us. Sir, please have few words.
नमस्कार और एक बार पूरा है रीजनल साइंस सेंटर भुवनेश्वर में मैं आप सभी का एक बार स्वागत करता हूं और सभी पार्टिसिपेंट्स को कांग्रेचुलेशन भी देता हूं कि आप सभी लोग डिस्ट्रिक्ट्स को रिप्रेजेंट कर रहे हैं, पूरे स्टेट का एक आप चेहरा हैं। तो आप सभी को एक बार स्टेट लेवल साइंस सेमिनार में आने के लिए बहुत बहुत धन्यवाद। और इस स्टेट लेवल साइंस सेमिनार जो राष्ट्रीय विज्ञान संग्रहालय परिषद और स्टेट एजुकेशन डिपार्टमेंट के सहयोग से हम लोग हर साल ऑर्गेनाइज करते हैं और हर साल इसमें कुछ नए चेहरे सामने आते हैं, कुछ ऐसे पार्टिसिपेंट्स आते हैं जो कहीं ना कहीं हमारे जजेस को, हमारे इस पूरे फॉर्मेट को प्रभावित करते हैं। और मैं जानता हूं कि आपका डिस्ट्रिक्ट लेवल का सफर भी बहुत अच्छा रहा होगा और उस डिस्ट्रिक्ट लेवल की प्रोसेस से आप विनर होकर आज स्टेट लेवल में पार्टिसिपेट करने आए हैं और यहाँ से आपका नेक्स्ट सफर जो यहाँ से विन करेगा वो विश्वेश्वरैया इंडस्ट्रियल एंड टेक्नोलॉजिकल म्यूजियम बेंगलोर जाकर वहाँ पर नेशनल लेवल कंपटीशन के लिए पार्टिसिपेट करेंगे। तो मैं सभी को बधाई देता हूँ, आप सभी लोग एंजॉय करें इस जर्नी को। ये एक लर्निंग प्रोसेस है और चूंकि इस सब्जेक्ट को जो आप देख रहे हैं कि क्वांटम एज, दिस इज द एज ऑफ क्वांटम, तो हमारे बीच ऐसे कुछ महान भाव हैं, कुछ ऐसे शख्सियत हैं जिन्होंने इस फील्ड में काफ़ी कुछ हासिल किया है और आपको उनके साथ भी इंटरेक्ट करने का मौका मिलेगा। मैं पूरे रीजनल साइंस सेंटर भुवनेश्वर और टी एंड SCRT की पूरी टीम के साथ में प्रोफेसर निहारिका मोहापात्रा उनका स्वागत करता हूँ। मैडम हेड ऑफ द डिपार्टमेंट फिजिक्स, इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी भुवनेश्वर, IIT भुवनेश्वर से हैं। आपका स्वागत है मैडम। और मैं स्वागत करता हूं प्रोफेसर प्रदीप कुमार साहू, इंस्टीट्यूट ऑफ फिजिक्स भुवनेश्वर। सर से थोड़ा ब्रीफ जानकारी मिला कि जो सर्न प्रोजेक्ट है आप सबने सुना होगा, किसी ने नहीं सुना क्या? सर्न प्रोजेक्ट LHC, तो सर उसके साथ जुड़े हुए हैं और काफ़ी कुछ रिसर्च वर्क उसमें कर रहे हैं। तो बहुत अच्छा एक मौका है आप सभी को ये जानने के लिए कि क्वांटम की फील्ड में क्या कुछ नया हो रहा है और हमारे जो साइंटिस्ट हैं वो किस लेवल पर इस पर रिसर्च कर रहे हैं। तो आपका बहुत बहुत धन्यवाद सर यहाँ आने के लिए। और कुछ ही बीच में एक बार जोरदार तालियों से हमारे पैनलिस्ट का स्वागत करें। और कुछ ही समय में हमारे साथ डॉक्टर मानस दलाई जो प्रिंसिपल साइंटिस्ट हैं IMMT भुवनेश्वर के, वो भी अभी कुछ ही समय में हमारे साथ जुड़ेंगे। तो आप सभी हमें सहयोग करेंगे। आपकी जो प्रोसेस है, जिस सेमिनार को आप प्रेजेंट करेंगे उसमें क्या कुछ इम्प्रोवाइजेशन की रिक्वायरमेंट है, किस तरीके से आप उसको और अच्छे बेहतर तरीके से प्रेजेंट कर सकते हैं और क्या कुछ सीख सकते हैं, तो उसके बारे में आपके साथ इंट्रोडक्शन करेंगे। और इस सेमिनार की जो गाइडलाइंस हैं आई थिंक आप सभी को पता है और कहीं भी आपका अगर कोई डाउट है तो हमारी जो टीम है वो आपके साथ है। कोई भी अगर आपको डाउट आता है, सारे टीचर्स और सारे स्टूडेंट्स को पूरे रीजनल साइंस सेंटर ऑर्गेनाइजेशन टीम की तरफ से बहुत बहुत शुभकामनाएं। और इसी के साथ मैं अनुरोध करूंगा कि मैं प्रलिप्ता मैडम से कि वो भी 2 शब्द हमारे बच्चों के साथ शेयर करें और किस तरीके से इस जर्नी को हम आगे और बेहतर तरीके से आप लोगों के सामने लेकर आएं। तो मैं एक बार रिक्वेस्ट करता हूं प्रलिप्ता मैडम से, तो प्लीज जस्ट शेयर अ फ्यू वर्ड्स।
थैंक यू सर। समस्त नमस्कार एवं जो प्रतियोगी मैंने आसी आम डिस्ट्रिक्ट लेवल सिलेक्ट होगी समस्त कंग्रेचुलेसन जे से ब्लॉक माने ब्लॉक लेवल रु डिस्ट्रिक्ट लेवल को आछन डिस्ट्रिक्ट लेवल रु स्टेट लेवल को आसीचंदी एवं स्टेट रो जदि माने जीतिबे से माने नेशनल लेवल रे मध्ये ओडिसा को रिप्रेजेंट करिवे तो से समस्त को धन्यवाद से भाई आ धन्यवाद देबा पर चाहिए जो टीचर माने गाइड टीचर माने आसीचंदी पिला माने संगे रे पिला माने को गाइड करचंदी पिपीटी प्रेजेंटेशन हो बा टॉपिक ऊपर जो गाइड करचंदी से माने धन्यवाद एवं आमे तो पूरा दिन एक संगे रहिबा निज निजर टॉपिक जहाँ अच्छी हमर जो क्वांटम रेस बिगिंस करके जो टॉपिक अच्छी ता विषय निजे तो प्रिपेयर हेतिबा ही किंतु अन्य माने जो माने अधिक प्रिपेयर करथिबे किछि अधिक कथा सेटा भी हमें सुनिबा एमती नै कि खाली निज प्रिपरेशन को जानिबा तो एटा एक भलो अपॉर्चुनिटी हमर जा थीम अच्छी आज थीम ता विषय अधिक किछि जानिबा आमे फॉर्चुनेटली हम संगे अछंती निहारिका मैडम अछंती प्रदीप सर अछंती जो माने कि फिजिक्स फील्ड रे बहुत काम करिसंती एवं अपडेटेड अछंती तो तांको मध्ये तांको से इंटरेक्शन करबा जहा किछि डाउट अछि ए थीम रिगार्डिंग आपण माने चाहिए पिला माने पचारि परिबो एवं समस्त को आउथरे कांग्रेचुलेशन एवं बेस्ट ऑफ लक आउ कि हेले जड़े विनर हबो किंतु आमे स्पोर्ट्समैन स्पिरिट सहित समस्त पार्टिसिपेट हल रे करबा जी भी विनर हो ताको भी कांग्रेचुलेट करबा एवं निजे किछि मनोयोग करबा नै ठीक अछि ओके तले हम स्टार्ट करबो मैं ठीक कहियो
थैंक यू सो मच मैडम। और एक बार फिर से आप इस सब्जेक्ट को जब प्रेजेंट करें तो आप बिल्कुल स्ट्रेस फ्री रहें, ये किसी तरह का कोई जजमेंट नहीं है, इट्स ए लर्निंग प्रोसेस। जैसे हमने बताया कि ये केवल एक सीखने की प्रक्रिया है और क्वांटम अपने आप में एक बहुत बड़ी दुनिया है ना। तो आप इसको एंजॉय करें और हम समय मिलेगा तो रीजनल साइंस सेंटर की तरफ से आपको कुछ नई चीज़ें भी दिखाने का प्रयास करेंगे। यहाँ एक नई फैसिलिटी ओपन हुई है, नॉलेज ऑन स्फीयर। तो हम कोशिश करेंगे कि इस प्रक्रिया में अगर कहीं समय मिलेगा तो आपको वो फैसिलिटी जरूर दिखाएंगे। और जब ये कंपटीशन कंप्लीट हो जाएगा, आपसे अनुरोध है कि आप जरूर रीजनल साइंस सेंटर को भी विजिट करके जाएं और आप हमारे नेटवर्क के साथ जुड़े रहें, है ना। इसी भावना के साथ एक बार मैं सभी को पूरी तरीके से कांग्रेचुलेट करता हूँ एंड एंजॉय दिस मोमेंट, है ना। डोंट बी स्ट्रेस्ड, है ना, एंड फाइंड आउट हाउ टू यूटिलाइज दिस टाइम, है ना। So thank you everyone, all the teachers, all the participants and every one of you and including our judges. Thank you everyone. Let's start with the state level science seminar 2025. Thank you.
Thank you so much. Thank you so much, sir, for having very good introduction and have encouraged all the participants to get in. So before we go for this one, like we have to give you some of the sorts of the rules and regulation about this one. So all this sort of, because now this is all the digital. So I hope all the 30 participants is giving their PPT over here. So apart from that one, only you have to get those 6 minutes of time. I have to request Abhinandan, please be shown over the screen the 6 minutes of time. It was already there on the either side also will come up. That's 6 minute timing, and the center screen should be shown over the presentation of individual, that means your PPT will be there. So the PPT time will be 6 minutes of there. So we will get it to buzzer, that is the opening buzzer, then the warning buzzer, and the last one is the complete buzzer, that is 6. That is opening, that means starting of your presentation, that means when time will be set, that means when you will be get ready, when judges will be get ready, and our timekeeper will be get ready, that time your countdown will be started. From there, from 0 to it will go to this 5 minutes, and after 5 minutes there is a warning alarm will be there. Then after that, the complete alarm will be there for the 6 minutes. This is the time period. And after that one, your mic will be muted and you will go towards the judges so that you can have a question answer session. And therefore the question answer session should be throw away 3 questions over there and you have to answer 2 of them. And for that one, you will get some 2 minutes. So that time should be kept by the only our judges. And after that one, you can only use 5 number of slides, because so many teachers are telling me the introduction and the closing, that was not required, because only the things is what may the content you have been pick up along with you, that you have to show over that and present your skills, that what sort of the knowledge that you have been learned or you want to be delivered to someone. That is the most important part. That was so these are the 2 rules was there. And apart from this one, early in the morning we have already completed our aptitude test. Out of 20 questions, 10 marks has been completed. Then after that one, now the presentation part will come up. Over the scientific content, you will be presentation the 40 marks. That was the most important point. 40 marks, how much you will be grabbed, that you have to impress your judges and the audience. Then after that one, you will get 25 marks on the fluency in speech. Now how you deliver your word and sentences. That is your 25 marks. Then question and answer session, that will be 10 marks will be there. So out of 3 questions, you have to answer 2 questions. And after that, novelty in visuals. And the most last point, that is your visuals. How you have to present your visual, that is 15 marks. So along this one, aptitude test is 10 marks. Then your scientific content 40 marks. Fluency in speech 25 marks. Questions and answer session for the 10 marks. And novelty in your visuals, that is your 15 marks. So in this, you will add all this one, you will get the 100 marks. So that means you will be judging by the 100 marks. And out of 100 marks, let me know how much you will secure that one. Visa for that was in our 30th of this month, that is October 30, in our Bangalore. That is our Visvesvaraya Industrial Technological Museum, VITM. They are also eagerly waiting our response, because we are in the Bihar, only the states, they have been doing same day, state level science seminar. Hope all the best to all the participants, all the teachers, all the guide. So only one request to all the guide teachers and the parents, please mute your mobiles, silent that one. And if you have any work, please without disturbing the hall, you can stay, you can roam around our galleries and the campus, also the facilities, whatever will be there, and you can be roam around in our all the sort of advertisement that we have been done over there. So thank you all. Hopefully we will be start. So one of the judges is on the way, so he will be there. So don't worry about that. We will go accordingly. So I hope all the participant order has been prepared 1 to 30, and 1 and 2 has been get ready for yourself. Knowledge. So may I have to request the participant from Jaspur. Time has been started right now.
A warm and respectful morning to one and all present here. This is Vidyanshi from Odisha Adarsh Vidyalaya Uttarpur. So before going to the topic, I want you to think about something. The phone in your pocket, the light in this room, and everything that we can see and touch have some source of rules. And that we call the classical physics. But what if I told that there was a hidden one left behind with completely different and magical source of rules? Yes, today I am here to talk about that word. So welcome to the quantum age. What is quantum? Quantums comes from a Latin word which literally means how much. At tiny scales, the particles behaves like a wave, and the act of measuring can change its behavior. It sounds strange, but it is true that it has already powered the everyday tech like the LED bulbs, the MRI scanners, and even to the computer chips. This incredible story has begun over 100 years before. In the year of 1900, Max Planck proposed that the energy is quantized. Then in 1905, Albert Einstein explains the photoelectric effect showing the particle nature of the light. Then in 1930, Niels Bohr gives us the atomic model. Then finally in the year of 1920, two scientists named Schrödinger and Heisenberg gives us the mathematical source of rules for this quantum techniques. Now the question will be came in your mind, why this is called as the quantum age? Because we became the master of this tiny relapse. To understand this, we have to evaluate two key ideas. The first one is the superposition. A normal computer bit is just like a license. It can be off, that we call 0, or on, that we call 1. But when we talk about a qubit, it's completely different and magical. It can be both 0 and 1 at one time. It's just like spinning a coin. The probability of getting head and tail is at the same time, which further result in solving millions of calculations problems within some seconds. Then the second one is the very strange, and that we call entanglement. If we join two qubits together, they just perform like a perfect twin. We can simply say that they share one combined quantum state even if they are in the distance. Even Einstein was puzzled by this and called this entanglement as a spooky action. With these two key ideas, there are so many unimaginable potential of these quantum techniques. The first one is quantum computing. It's very helpful to solve complex problems within some seconds. Drug discovery will be done by designing atom by atom. Personalized treatment should be given by this. and it also helps in the development of our super intelligent AI. Also helps in creating the batteries that would never die. The second one is the quantum communication and encryption. Nowadays, it became very easy to hack someone's personal detail or phone. But this quantum communication is ultra secure. Means if a spy tries to hack our account, we will be immediately alerted by these techniques. Then the third one is the quantum sensing. The quantum sensors are very sensitive. Means they even detect the small actions that will be happening in our brain. The diseases like Alzheimer's, cancers are being detected by these quantum sensors. This quantum sensor also helps in navigating the seas without its GPS. Then the fourth one is quantum teleportation. Yes, quantum teleportation is real, but it doesn't mean that it teleports the people. Rather, it should teleport the quantum information from one place to another place. It's a crucial step towards making the quantum internet the super fast internet in the world. Besides so many potential, there are so many hurdles on the path of this quantum. The first and the foremost was the fragility problem that we call the decoherence. The quantum, the qubits are very delicate and sensitive, just like a bubble. The small noise, vibration can destroy the quantum state of a qubit, which is a very big problem for us. The second one is the conceptual and engineering hurdle. The quantum computers are too big and complex as they are the computer that we see in the 1950s. They only work under the cold temperature, which is very difficult to be maintained at different times. At the last, finally we came to the ethics. The super fast and the developed quantum computer could break, and they could break all the password and encryption that protects our national security, our passwords, etc., which is a very big problem for us. We should ensure that the quantum age benefit all the nations equally. One nation should not dominate the other nation by this. Rather, the development should be equal distributed among all the countries. Now we see some of the future of this quantum and India's lead. The companies like Google and IBM has already made their quantum processors, which help them a lot. And I'm incredibly sad that our India is not just watching the race, but also participating running in it. Our Indian government has launched the National Quantum Mission of over 6,000 crores. The aim was very bold and simple, to make our India the global leader of these quantum techniques. Yes, this is not just the friction of the science, it's a global race that was happening right now. At the last, I want to tell that quantum age has just begun. The question is no longer if it will change our world, but how fast. Thank you, have a great day.
Can you give some example of quantum?
Sir, photon, if we take the photon, energy is considered as the plant's age and the frequency. H is considered as Planck's constant. Electrons are also considered as quantization.
System, quantum system, classical system.
Yes, in the first when we talk about the classical system, we are working with the lab object, but while we came to the quantum, it's about the soft atomic particle levels. Means the quantum system can do that work which a classical computer cannot. For example, it's become very easy to hack a classical computer. While it comes to the quantum computer, it's very difficult to be hacked because we use the quantum key distributions.
But I have one system here.
Yes, sir.
How do you distinguish quantum system in the classical? How do you distinguish?
Sir, with the principle that we call the superposition. Superposition means the classical computer, if the classical thing can only be 0 or 1 at one time. Sorry, only 1 or 0. But while we talk about the quantum computer, it can be both 0 and 1 at one time. This 0 and 1 it talks about its voltage.
What Sar asked related to that. And at which level you will apply quantum mechanics and classical mechanics? How do you distinguish? What is the transition point?
Nowadays, we are using the classical techniques more than the quantum techniques. In future, when all the encryption and
the details, then I should go. I have now
Which
what I am
stage?
What stage I will go to that.
when classical computers are not perform the task, means at the time that a quantum computer can
When
do.
you don't say, you don't know. When you know, that's it.
ସମସ୍ତଙ୍କୁ ମୋର ଶୁଭ ସକାଳ ସମ୍ମାନନୀୟ ବିଚାରକ ମଣ୍ଡଳୀ ଏବଂ ମୋର ପ୍ରତିଯୋଗୀ ବୃନ୍ଦ ଏବଂ ଅତିଥିଗଣ ମୁଁ ସ୍ନେହାଞ୍ଜଳି ପଣ୍ଡା ନୀଳମଣି ସରକାରୀ ଉଚ୍ଚ ବିଦ୍ୟାଳୟର ନବମ ଶ୍ରେଣୀର ଛାତ୍ରୀ ମୁଁ ଗଜପତି ଜିଲ୍ଲା ସୁଦୂର ରାୟଗଡ଼ ବ୍ଲକରୁ ଉପସ୍ଥାପନ କରୁଛି ମାନବ ଇତିହାସ ବିଭିନ୍ନ ଯୁଗ ଦ୍ୱାରା ପରିଚିହ୍ନ ପାଥର ଯୁଗ ଔଦ୍ୟୋଗିକ ଯୁଗ ସୂଚନା ଯୁଗ ବର୍ତ୍ତମାନ ଆମେ ପଦାର୍ପଣ କରୁଛୁ କ୍ୱାଣ୍ଟମ୍ ଯୁଗରେ ଏହି ନୂତନ ଯୁଗର ଗଠନ ଦ୍ରୁତ ବିଜ୍ଞାନ ଓ ପ୍ରଯୁକ୍ତି ବିଦ୍ୟା ଦ୍ୱାରା ସମ୍ଭବ ହୋଇଛି ତ ମନରେ ପ୍ରଶ୍ନ ଉଙ୍କି ମାରୁଥିବ ଯେ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ କ'ଣ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ କହିଲେ କୌଣସି ଐତିହାସିକ ସମୟକୁ ବୁଝାଯାଏ ନାହିଁ ବରଂ କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର କ୍ୱାଣ୍ଟମ୍ ମେକାନିକ୍ସକୁ ବୁଝିବା ତାହାକୁ ପ୍ରୟୋଗ କରି ବର୍ତ୍ତମାନ ଚାଲିଥିବା ପ୍ରଯୁକ୍ତିଗତ ଅଗ୍ରଗତିକୁ ସୂଚିତ କରେ ତ କ୍ୱାଣ୍ଟମ୍ର ସିଦ୍ଧାନ୍ତ କ'ଣ କ୍ୱାଣ୍ଟମ୍ର ଅର୍ଥ ହେଉଛି ଶକ୍ତି କିମ୍ବା ପଦାର୍ଥର ସବୁଠାରୁ କ୍ଷୁଦ୍ରତମ ଅଂଶ ସାଧାରଣ ଭୌତିକ ବିଜ୍ଞାନ ଠାରୁ ଏହା ସମ୍ପୂର୍ଣ୍ଣ ଅଲଗା କ୍ୱାଣ୍ଟମ୍ ଫିଜିକ୍ସ କୁହେ ଯେ ଇଲେକ୍ଟ୍ରନ୍ କିମ୍ବା ଫୋଟନ୍ ଏକ ସମୟରେ ଉଭୟ ତରଙ୍ଗ ଓ ପଦାର୍ଥ କଣିକା ପରି ଗୁଣ ପ୍ରଦର୍ଶନ କରିଥାନ୍ତି କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ହେଉଛି ନୂତନ ପ୍ରଯୁକ୍ତିଗତ ଯୁଗ ଯାହା କ୍ୱାଣ୍ଟମ୍ ମେକାନିକ୍ସର ନୀତିମାନ୍ୟ ଉପରେ ଆଧାରିତ ତ ଜାଣିବା କ୍ୱାଣ୍ଟମ୍ର ଇତିହାସ କ୍ୱାଣ୍ଟମ୍ ଧାରଣାର ଆରମ୍ଭ 1900 ମସିହାରେ ମ୍ୟାକ୍ସ ପ୍ଲାଙ୍କଙ୍କ ଦ୍ୱାରା ଆରମ୍ଭ ହୋଇଥିଲା ତାଙ୍କ ମତ ଅନୁସାରେ ପଦାର୍ଥର ଶକ୍ତି ଛୋଟ ଛୋଟ ପ୍ୟାକେଟରେ ରହିଥାଏ ଯାହାକୁ କ୍ୱାଣ୍ଟା କୁହାଯାଏ ପରେ ଆଲବର୍ଟ ଆଇନଷ୍ଟାଇନ ନିଲ୍ ବୋର୍ ଅରବିନ୍ଦ ଶ୍ରୋଡିଙ୍ଗର ଏହାକୁ ଆଗକୁ ନେଇ କ୍ୱାଣ୍ଟମ୍ ମେକାନିକ୍ସ ଆରମ୍ଭ କରିଥିଲେ କ୍ୱାଣ୍ଟମ୍ ମେକାନିକ୍ସର ଅର୍ଥ କ'ଣ କ୍ୱାଣ୍ଟମ୍ ମେକାନିକ୍ସ ହେଉଛି ଏକ ପଦାର୍ଥ ବିଜ୍ଞାନର ଶାଖା ଯାହା ପରମାଣୁ ଓ ଅପପରମାଣବିକ ସ୍ତରରେ ପଦାର୍ଥ ଓ ଶକ୍ତିର ବ୍ୟବହାରକୁ ବର୍ଣ୍ଣନା କରାଯାଇଥାଏ ତ କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ଆରମ୍ଭ କେତେବେଳେ ହୁଏ କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ଆରମ୍ଭ ସେତେବେଳେ ହୁଏ ଯେତେବେଳେ କ୍ୱାଣ୍ଟମ୍ ଯାନ୍ତ୍ରିକତା କେବଳ ଏକ ସୂତ୍ରୀୟ ଧାରଣାରୁ ବାସ୍ତବ ପରିବର୍ତ୍ତନଶୀଳ ପ୍ରଯୁକ୍ତି ବିଦ୍ୟାର ଭିତ୍ତିଭୂମିରେ ପରିଣତ ହୋଇଥାଏ ଏହି ଯୁଗର ସମ୍ଭାବନା ଥାଏ କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟିଂ କ୍ୱାଣ୍ଟମ୍ କମ୍ୟୁନିକେସନ କ୍ୱାଣ୍ଟମ୍ ସେନ୍ସିଂ ସୁପରପୋଜିସନ ଓ ଏଣ୍ଟାଙ୍ଗଲମେଣ୍ଟ ଏହିପରି ଜଟିଳ ସମସ୍ୟାମାନଙ୍କୁ ସମାଧାନ କରିପାରିବ ଯାହା ପାରମ୍ପରିକ କମ୍ପ୍ୟୁଟର ଦ୍ୱାରା ଅସମ୍ଭବ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ଅର୍ଥ କରେ କ୍ୱାଣ୍ଟମ୍ ଧାରଣା କେବଳ ପୁସ୍ତକରେ ନୁହେଁ ବାସ୍ତବ ଜଗତରେ ପ୍ରୟୋଗ ହୋଇ ଦୈନନ୍ଦିନ ଜୀବନକୁ ପ୍ରଭାବିତ କରୁଛି ଏବଂ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ଯାହା ପୂର୍ବରୁ ଏକ ସିଦ୍ଧାନ୍ତ ଥିଲା ବର୍ତ୍ତମାନ ପ୍ରଯୁକ୍ତିର ଆଧାର ହୋଇଯାଇଛି ତ ଜାଣିବା ଏବେ କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ପ୍ରୟୋଗ ରସାୟନ ପ୍ରୟୋଗ ଲେଜରର ପ୍ରୟୋଗ କ୍ୱାଣ୍ଟମ୍ ପ୍ରଯୁକ୍ତିର ପ୍ରୟୋଗ ପଦାର୍ଥ ବିଜ୍ଞାନର ପ୍ରୟୋଗ ଏମିତି ପ୍ରୟୋଗ ଦ୍ୱାରା କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ସମ୍ଭାବନା ହୋଇଥାଏ ତ ଜାଣିବା ଏବେ କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ସମ୍ଭାବନା କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟିଂ ସାଧାରଣ କମ୍ପ୍ୟୁଟର ଦ୍ୱାରା ଅସମ୍ଭବ ସମସ୍ୟାଗୁଡ଼ିକୁ ଏହା ସମାଧାନ କରିପାରିବ କ୍ଲାସିକାଲ କମ୍ପ୍ୟୁଟର ଯେଉଁଠାରେ ବାଇଟ୍ସ 0 ଓ 1 ବ୍ୟବହାର କରେ ଯାହା ଏକ ସମୟରେ ଅନେକ ପରିସ୍ଥିତିରେ ରହିପାରେ କିନ୍ତୁ କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର କ୍ୟୁବିଟ୍ସରେ ତଥ୍ୟ ସଂଗ୍ରହ କରେ ଯାହା ଏକ ସମୟରେ ଦୁଇଟି ପରିସ୍ଥିତିରେ ରହିପାରେ ଏହା ଜଟିଳ ସମସ୍ୟାମାନଙ୍କୁ କିଛି ସେକେଣ୍ଡରେ ସମାଧାନ କରିପାରିବ କ୍ୱାଣ୍ଟମ୍ କମ୍ୟୁନିକେସନ ଏଣ୍ଟାଙ୍ଗଲମେଣ୍ଟ ବ୍ୟବହାର କରି ସୁରକ୍ଷିତ ସଂଯୋଗ ପ୍ରଦାନ କରି ଅଭେଦ୍ୟ ଗୁପ୍ତଲିପିକରଣ QKD କ୍ୱାଣ୍ଟମ୍ କି ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ ସମ୍ଭବ କରିଥାଏ କ୍ୱାଣ୍ଟମ୍ ସେନ୍ସିଂ ଗୋଟିଏ ସୁନିର୍ଦ୍ଦିଷ୍ଟ ସେନ୍ସିଂରେ ବିକାଶ କରି ଯାହା ନାଭିଗେସନ ଡାଇଗ୍ନୋସିସ୍ ଏବଂ ବୈଜ୍ଞାନିକ ଅନୁସନ୍ଧାନରେ କ୍ରାନ୍ତି ଆଣିପାରିବ ସୁପରସୋନିକ ଓ ଯୋଗାଯୋଗ କ୍ୱାଣ୍ଟମ୍ ପ୍ରଣାଳୀରେ ତିଆରି ହେଉଥିବା ସିକ୍ୟୁରିଟି କୋଡକୁ ଭାଙ୍ଗିବା ପ୍ରାୟ ଅସମ୍ଭବ ଯାହା ଫଳରେ ଦରକାରୀ ତଥ୍ୟଗୁଡ଼ିକ ସୁରକ୍ଷିତ ରହିବ ସାଇବର ଠକେଇ ମଧ୍ୟ କମିଯିବ ତ 21ତମ ଶତାବ୍ଦୀରେ ଆମେ କ୍ୱାଣ୍ଟମ୍ ଯୁଗକୁ ପ୍ରବେଶ କରୁଛୁ କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର ସାଧାରଣ କମ୍ପ୍ୟୁଟର ଠାରୁ ଲକ୍ଷ ଲକ୍ଷ ଗୁଣରେ ଅତ୍ୟଧିକ ଦକ୍ଷ ଯାହା ଫଳରେ ସାଇବର ସିକ୍ୟୁରିଟି ବହୁତ ଶକ୍ତିଶାଳୀ ନୂତନ ଔଷଧର ଖୋଜା ଜଳବାୟୁ ସମ୍ବନ୍ଧୀୟ ସଠିକ ତଥ୍ୟ ମହାକାଶ ଏବଂ AI ଗବେଷଣା କ୍ଷେତ୍ରରେ ଅନେକ ଉନ୍ନତି ହୋଇପାରିବ ଭୌତିକ ପରିମାଣଗୁଡ଼ିକ ଯଥେଷ୍ଟ ଶକ୍ତିଶାଳୀ ଗୁଣଗୁଡ଼ିକରେ ପରିପ୍ରକାଶ ହୁଏନି ବରଂ ଛୋଟ ଛୋଟ ପ୍ୟାକେଟରେ ମିଳେ କିମ୍ବା ଦିଆଯାଇଥାଏ ଉଦାହରଣ ସ୍ୱରୂପ ଆଲୋକର କ୍ୱାଣ୍ଟମ୍ ହେଉଛି ଫୋଟନ୍ ତ ଏବେ ଜାଣିବା କ୍ୱାଣ୍ଟମ୍ ଯୁଗର ସମ୍ଭାବନା ହେଲା କିନ୍ତୁ କଥା ହବ ଯଦି ଏଥିରେ କ୍ୟୁବିଟ୍ ପଡ଼ିଲା ତେବେ ସ୍ଥିରଟା କଷ୍ଟସାଧ୍ୟ ହେବ କ୍ୱାଣ୍ଟମ୍ ଯାନ୍ତ୍ରିକତା ପ୍ରାୟ ସ୍ଥିର ତାପମାତ୍ରାରେ ରହି କାମ କରିବାକୁ ପଡ଼ିବ କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର ଅତ୍ୟଧିକ ବ୍ୟୟବହୁଳ ଏବେ ପର୍ଯ୍ୟନ୍ତ ଅନେକ କ୍ୱାଣ୍ଟମ୍ ଯାନ୍ତ୍ରିକତା ପରୀକ୍ଷଣ ଦଶାରେ ରହିଛି ତ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ କେବଳ ତେଜ କମ୍ପ୍ୟୁଟର କିମ୍ବା ସୁରକ୍ଷିତ ସମ୍ପ୍ରସାରଣ ନୁହେଁ ବରଂ ମାନବ କ୍ଷମତା ଓ କଳ୍ପନାରେ ନୂଆ ପରିଭାଷା ଯେପରିକି ସୂଚନା ଯୁଗ ଇଣ୍ଟରନେଟରେ ସମସ୍ତଙ୍କୁ ପରିବର୍ତ୍ତନ କରିଥିଲା ସେପରି କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ବିଜ୍ଞାନ ଓ ପ୍ରଯୁକ୍ତିର ଭିତ୍ତିକୁ ପୁନର୍ନିର୍ମାଣ କରିପାରେ ଯଦି ସୁବିଚାରିତ ଭାବେ ବ୍ୟବହାର କରାଯାଏ ତେବେ ମାନବ ଜାତିର ମହାନ ସମସ୍ୟାଗୁଡ଼ିକୁ ସମାଧାନ କରି ଏକ ନୂତନ ଓ ସଂସ୍ଥାୟୀ ଭବିଷ୍ୟତ ସୃଷ୍ଟି କରିପାରିବ ତ କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ବର୍ତ୍ତମାନ ଆରମ୍ଭ ସ୍ତରରେ ରହିଛି ଏଥିରେ ଅନେକ ଅସାଧାରଣ ସୁଯୋଗ ରହିଥିଲେ ମଧ୍ୟ ଅନେକ ପରିବର୍ତ୍ତନ ମଧ୍ୟ ରହିଛି ତ ଆଗାମୀ ଭବିଷ୍ୟତ କେମିତି ହେବ କ୍ୱାଣ୍ଟମ୍ ଯୁଗକୁ ନେଇକି ତାହା ନିର୍ଭର କରିବ ଯେ ମାନବ ଜାତି କେତେ ବୁଦ୍ଧିମତ୍ତାର ସହ ଏହି ଶକ୍ତିକୁ ବ୍ୟବହାର କରିପାରିବ ତ ବିଶ୍ୱବ୍ୟାପୀର ସହଯୋଗରେ ଏହି ଯୁଗକଣ ମହାନ ଯୁଗ ଆସିଲେ ମଧ୍ୟ ଆମେ ସାହସର ସମ୍ମାନର ଏବଂ ସହଜର ସହିତ ସମ୍ମୁଖୀନ କରିପାରିବା ଧନ୍ୟବାଦ
एमती गोटे प्रोब्लेम को जहाँ को आम क्वांटम मेकानिक्स बा क्वांटम नीति गुड़े यूज करके सॉल्व करते क्वांटम कंप्यूटर एपर्यंत बाहर चली रिसर्च चली जोटा आम ऑलरेडी सॉल्व कर पारिछु क्वांटम मेकानिक्स यूज करके से भले गोटे एग्जांपल को चिकित्सा कोटा हे पार नथिला सेटा करिछ कौन
चिकित्सा कहलो ठीक तो तादर बहुत एग्जांपल से क्वांटम मेकानिक्स बहुत माने तुम जहां बोले कहि दो हो तुम सब क्वांटम मेकानिक्स
Time out, please. Thank you. Position that you have to stand over there and judges will ask the questions and from that apart from the distance you have to answer. ठीक है दूर रे ठिया की जोटी प्रेजेंटेशन बोलो सेठी ठिया हो जजेस माने तम माइक धरि क्वेश्चन पचरबे और तमरा आंसर दो ना पाखो गला रो तुम बहुत स्लोली कथा होछ का को सुबुनी ठीक अछि Just we are ready participants we are ready so your countdown starts right now
सूक्ष्म कणों में छुपा है राज विज्ञान खुलेगा नया अंदाज क्वांटम का है ये आवाज अब बदलेगा हमारा समाज जय जगन्नाथ क्रमवर्धिष्णु ज्ञान पिपासा एवं विज्ञान राशि उपलब्धि को पाथ्य करी मनुष्य प्रस्तर जुग लघु जुग एवं प्रस्तर जुग लघु जुग ब्रोंज जुग एवं परिशेष इनफॉरमेशन जुग को अतिक्रम करी जे पदार्पण करी जे क्वांटम जुग रे ए क्वांटम जुग रे सोनेली भविष्य भितर मनुष्य खोजी ताहार परिचय ए क्वांटम जुग मनुष्य पई आनी देछि असीम आशा और संभावना एवं ता सहित आनी देछि अनेक असमाहित प्रश्न ए क्वांटम जुग रे सोनेली भविष्य भितर मनुष्य खोजी ताहार परिचय अनेक प्रश्न म मन रे उंकी मारुछि कोन है क्वांटम एवं कोन है भविष्य चलो तेर उत्तर खोजिबा नेक्स्ट स्लाइड क्वांटम शब्दटी लैटिन शब्द क्वांटस आसी जहार अर्थ हेउछि किछि निर्दिष्ट परिमाण बा किछि अंश 1900 मसीह जर्मन वैज्ञानिक मार्क्स प्लांक तकर जुगांतकारी फॉर्मूला E=hf माध्यम रे क्वांटम शब्दर अवधारणा करथिले पदार्थर भौतिक प्रकृति वस्तुत्व शक्ति व चार्ज रे सूक्ष्म एकक को हम क्वांटम बोली कहथा तांग भाषा रे क्वांटम साइंस रे संज्ञा हेउछि क्वांटम साइंस इज अ ब्रांच ऑफ फिजिक्स दैट डिस्क्राइब्स द बिहेवियर ऑफ मैटर एंड एनर्जी एट द एटॉमिक एंड सबएटॉमिक लेवल एक्सप्लेनिंग phenomena that differs from the rules of classical physics क्वांटम साइंस रा असीम संभावना को उपलब्धि करी यूएनओ 2025 वर्ष को इंटरनेशनल ईयर ऑफ क्वांटम साइंस एंड टेक्नोलॉजी वर्ष रूपे घोषणा करी 2025 वर्ष रे नोबेल पुरस्कार पाइथिबा विजेता गुडी हेउछन जॉन क्लार्क माइकल डिवर जॉन मार्टिनिस दे डिस्कवर्ड मैक्रोस्कोपिक क्वांटम मैकेनिकल टनलिंग एंड एनर्जी क्वांटाइजेशन इन एन इलेक्ट्रिकल सर्किट क्वांटम सुपरपोजिशन quantum concept superposition entanglement interference quantum tunneling no-cloning theorem wave particle duality uncertainty principle quantum speed quantum scarce coherence और decoherence तो आज ये क्वांटम टेक्नोलॉजी हम पाए असुमारी संभावना गुडिक मध्ये नै अछि तो संभावना क्षेत्र गुडिक हला क्वांटम कंप्यूटिंग सिक्योर कम्युनिकेशन क्वांटम सेंसिंग साइबर सिक्योरिटी क्वांटम इमॉर्टैलिटी एआई और मशीन लर्निंग जातीय प्रतिरक्षा परिवेश और जलवायु कृषि और खाद्य सुरक्षा स्वास्थ्य और चिकित्सा शिल्प और अर्थनीति परिवहन और लॉजिस्टिक्स विज्ञान और प्रযুক্তি विद्या सामाजिक प्रभाव अंतरिक्ष गवेषणा आर्थिक विश्लेषण और व्यापार आईन और प्रशासन मनोरंजन और मीडिया ग्लोबल सहयोग और ऊर्जा क्षेत्र क्वांटम कंप्यूटिंग साधारण कंप्यूटर थारे 100 गुण द्रुत गति रे काम करि परथे क्वांटम कंप्यूटर क्वांटम बिट्स का क्यूबिट्स ने कार्य करते हैं एक समय उभय 0 और 1 को सुपरपोजिशन तत्व अनुसार पैरेलल डाटा को प्रोसेसिंग करते तेनु हे सठिक एवं क्षिप्र गति रे कार्य करि परथे एंटांगलमेंट तत्व अनुसार यह गोटे बिट को परिवर्तन कले यह प्रभाव अन्य को क्यूबिट्स ऊपर पड़िଥାଏ एबे क्वांटम कंप्यूटर के व्यवहार करी जलवायु सठिक पूर्वानुमान रोगर सठिक निरूपण सहज रे निर्धारण रूपे करा जाय पारुछि यह इलेक्ट्रॉनिक रे नूतन क्षेत्र अटे जहां क्वांटम स्टार्स व्यवहार करी क्वांटम स्टार्स व्यवहार करी एनर्जी एफिशिएंसी को सहज रे निर्धारित करा जाय पारुछि जातस्य मरणम ध्रुव एही उक्ति को भविष्य रे बहुत प्रमाणित करबा जाउछि एलन मस्क न्यूरालिंक कंपनी एवं क्वांटम साइंस यह एक चिप विकसित करबा जाउछि जो चिप र नाम भी सहज रे एही चिप पूरी प्रोग्रामिंग करा जाय मनुष्य मस्तिष्क को कार्यक्षम करा जाय परिबा फल रे डिजिटल दुनिया रे मनुष्य होई जिवो अमर यह एक आधुनिक एआई रोबोट जहाँ मनुष्य पर मिसी कार्य करि पारे लॉजिस्टिक्स पैकेजिंग एवं प्रोडक्शन इंडस्ट्री क्षेत्र रे व्यवहार फल उत्पादन र परिमाण को बहुल मात्रा रे बढ़ा जाय परिबो ईवी रो व्यवहार बढ़िबा सहित एहर चार्जिंग समस्या मध्ये दिन दिन बढ़ी चली पारंपरिक लिथियम आयन बैटरी परिवर्ते भविष्य रे क्वांटम बैटरी रो व्यवहार हेबो एथिरे व्यवहृत ऑप्टिकल कैपेसिटी सुपर एब्जॉर्प्शन प्रिंसिपल एहर अल्ट्रा फास्ट चार्जिंग पुश एनर्जी स्टोरेज कैपेसिटी द्विगुणित करि परिबो एनर्जी ग्रिड मानकरे व्यवहृत एल्युमिनियम और कपर धातु परिवर्ते पारंपरिक क्वांटम सुपर कंडक्टर मानक व्यवहार फल एनर्जी लॉस परिमाण को बहुल मात्रा रे कमा जाय परिबो आजकल क्वांटम सेंसर व्यवहार फल बहु कठिन कार्य को मध्य सहज रे करा जाय पारुछि कृषि क्षेत्र रे माटीर गुणवत्तार सठिक निरूपण एवं जलवायु सठिक निरूपण मध्य या द्वारा सहज रे सुविधा रे करा जाय पारुछि ए क्वांटम डॉट सेंसर व्यवहार द्वारा जल प्रदूषकर मात्रा एवं वायु प्रदूषकर मात्रा को सहज निर्धारित करा जाय पारुछि अपन मैंने आईवीएफ का इनविट्रो फर्टिलाइजेशन का निश्चित सुनिथिबे मात्र मेडिकल साइंस रे बायोटेक्नोलॉजी एवं क्वांटम टेक्नोलॉजी रे मिलित प्रयास होछि इनविट्रो जेमटोजेनेसिस बा आईवीजी एही पद्धति रे मनुष्य पुरुष व स्त्री रो सोमैटिक कोष तथा चर्म और मांसपेशी रो स्टेम सेल टेक्नोलॉजी जरिया रे शुक्राणु एवं डिंबाणु उत्पन्न करि हेबो फल पिलाटी जन्म पड़िबो ना स्त्री को पुरुषर आवश्यकता पड़िबो एहा को मेडिकल भाषा सिंगल सेक्स रिप्रोडक्शन बोली कहा जाय थे क्रिस्पर टेक्नोलॉजी और क्वांटम टेक्नोलॉजी रे एक मिलित प्रयास होची जुलजमा वैक्सीन जहाँ एक एसएमए बा स्पाइनल मस्कुलर एट्रोफी भली रोग पर एक वरदान पालटिछि मात्र एही दुखर कथा जे एही वैक्सीन रो सिंगल डोज रो मूल्य 18 कोटी टंका एवं यह मध्य भारत में उपलब्ध नुहे अपन मैंने पेट्रोल इंजिन डीजल इंजिन इलेक्ट्रिकल इंजिन और सीएनजी इंजिन विषय निश्चित शुणिथिबे मात्र सीएनजी इंजिन एक सरती उत्स होइतिबा बेले पेट्रोल एवं डीजल प्रदूषक एक मुख्य उत्स होइଥାଏ मात्र भविष्य में यह सब इंजिन स्थान नेबाक जाउछि AQHE बा ऑटोनोमस क्वांटम हीट इंजिन एही क्वांटम टेक्नोलॉजी का सहित अनेक गुडी आह्वान मध्य आपे सृष्टि करछि तो से आह्वान क्षेत्र गुडी कहला टेक्निकल इश्यू अर्थनीतिक आह्वान साइबर सुरक्षा आह्वान दक्ष कुशल मानव संबल अभाव नैतिक और सामाजिक आह्वान पारिवेशिक समस्या नियुक्ति हराइबार भय क्यूबिट्स अवस्थार अस्थिरता समस्त अनुपलब्धता उच्च गवेषणा पे अर्थर अभाव क्वांटम गवेषणा पे आवश्यक भित्तिभूमि विकास जटिल एल्गोरिथम समस्त बुझिबाक अक्षम क्वांटम कंप्यूटर व्यवहार जोगु मनुष्यर कार्यदक्षता ह्रास शक्तिर अभाव क्वांटम कंप्यूटर मालफंक्शनिंग आह्वान साइबर क्राइम भय तथ्य गोपनीयता प्रति विपद
Your time is up.
Can you just elaborate? ଟିକେ ଡିଟେଲରେ ବୁଝେଇ କହିବେ କ୍ୱାଣ୍ଟମ୍ ବ୍ୟାଟେରୀ ରେସ୍ एनर्जी स्टोरेज केमती बेटर हबो कंपेयर टू क्लासिकल बैटरी
मैम जो क्वांटम बैटरी पूर्व जो बैटरी व्यवहार करा जाउची सेत्रे लिथियम आयन जोटा व्यवहार करा जाउची से एबी बा इलेक्ट्रॉनिक वेहिकल एथे जो बैटरी व्यवहार करा जाउची तो सेटा हम पे चार्जिंग समस्या पड़तो सेटा हम एक गुरुत्वपूर्ण विपद आनि परछि मतलब हम क्वांटम बैटरी व्यवहार सुपर कंडक्टर व्यवहार करबा पड़े सेत्रे जो लिथियम आयन तो लिथियम आयन माने जो रिचार्जेबल एक एनर्जी कैपेसिटी जहाँ एनर्जी स्टोरेज को द्विगुणित करि पाइबा एहा पर
सुपर कंडक्टर यूज करबा बदल रे केमती हमें हमको रिचार्ज करे को न पड़े सेटा टिके बुझियो
क्वांटम सेंसर रे क्लासिकल सेंसर क्वांटम सेंसर डिफरेंस सेंसर तो क्या है तो क्वांटम टेक्नोलॉजी यूज एक एग्जांपल दियो हम डेली लाइफ में यूज करते हैं
हम क्वांटम कंप्यूटर डेवलप हबो
एई हम ना देख सकते
तुम्हारा जो लास्ट स्लाइड रे कहला ना एवोशन नोबेल प्राइज क्वांटम टनलिंग विषय किछ कहि परिबो कोन
टनल अर्थ गर्त व गात तो जदि माने गोटे कणिका पाखरे पर्याप्त परिमाणर एनर्जी नथिले मध्य से प्रतिबंधक व बैरियर मध्य दे क्रॉस कर पाए एटा हम क्वांटम टनलिंग कहते
केमते क्रॉस कर यहाँ पर सुपर कंडक्टर जो सुपर कंडक्टर कौन था
अति परिमाण जोटा कि एनर्जी बहुत जोर स्पीड रे प्रवाहित होई पाए
कंडक्टर सुपर कंडक्टर दीटा दिन्छ कंडक्टर जान्छ ना एटा अति जो बोल सुपर कंडक्टर तो तार जे तुम बेसिक माने डेफिनेशन तुम करिवे अवश्य कम पाई नो ये एडवांस दिन सब क्लास ना प्रोजेक्ट तो प्रिपेयर हि जाओ तो टिकट तो जानि थबो ना
सुपर कंडक्टर तो टीएमजी के जोटा
को क्लास
10
क्लास में तो कंडक्टर इंसुलेटर बड़ा सब पढ़ाई थबो ना ठीक है ये जो मेडिसिन ता देखले लोग 200 कोटी ना केते बोलो
18 कोटी
ओके क्वांटम
सर क्वांटम मतलब क्रिस्पर टेक्नोलॉजी हमर जो क्वांटम टेक्नोलॉजी मिसिकी से मेडिसिन ता होची जो सेटा मेडिसिन ता के होची एसएमए होबो स्पाइनल मस्कुलर एट्रोफी जो होबो होची
Thank you so much.
us in such a short notice, and I hope we all will get to know many more things on this particular subject through the interactions. And I request all the participants to be confident. Don't lose your confidence and give the answers to the questions whatever you know. It's not the final competitions. You just try to give the answers whatever the information that you have, and be loud enough so that everyone in the hall should listen at what you are giving the reply to the questions. This is only the request. Thank you.
So next participant is Katak, and the serial number is 5. All right. So hope the judges and participants get ready. So will we start your countdown right now.
नमस्कार, ମୁଁ ହେଉଛି ପୁନମ ମିହିର, ତୁଗଲା ଉଚ୍ଚ ବିଦ୍ୟାଳୟର ଜଣେ ଛାତ୍ରୀ। ଆଜି ଆମ ସେମିନାରର ବିଷୟବସ୍ତୁ ହେଉଛି କ୍ୱାଣ୍ଟମ୍ ଏଜ୍ ବିଗିନ୍ସ, ପୋଟେନ୍ସିଆଲ ଆଣ୍ଡ ଚ୍ୟାଲେଞ୍ଜେସ୍। କ୍ୱାଣ୍ଟମ୍ ବିଜ୍ଞାନ କେବଳ ବିଜ୍ଞାନ ପରିକଳ୍ପନାର ଏକ ଧାରଣା ନୁହେଁ, ବରଂ ଏହା ଆମ ଦୈନନ୍ଦିନ ଜୀବନରେ ପରିବର୍ତ୍ତନ ଆଣିବା ଏବଂ ଆମ ଭବିଷ୍ୟତକୁ ସୁଦୃଢ଼ କରିବାରେ ଏକ ଗୁରୁତ୍ୱପୂର୍ଣ୍ଣ ଭୂମିକା ଗ୍ରହଣ କରିଛି। ସର୍ବପ୍ରଥମେ ଆମେ ଜାଣିବା ଏହି କ୍ୱାଣ୍ଟମ୍ ଯୁଗ କ'ଣ, କାହିଁକି ଆମେ ଏହି କ୍ୱାଣ୍ଟମ୍ ଯୁଗ ମଧ୍ୟରେ ପ୍ରବେଶ କରୁଛୁ। ଆପଣମାନେ ଜାଣିଥିବେ ଶିଳ୍ପ ଯୁଗ, ଯାହା ଥିଲା ବାଷ୍ପ ଏବଂ ଯନ୍ତ୍ରର ଯୁଗ। ଆପଣମାନେ ଜାଣିଥିବେ ସୂଚନା ଯୁଗ, ଯାହା ଥିଲା କମ୍ପ୍ୟୁଟର ଏବଂ ଇଣ୍ଟରନେଟର ଯୁଗ। ଆଜି ସେହିପରି ଆମ ସମସ୍ତଙ୍କ ଆଗରେ ଅଛି କ୍ୱାଣ୍ଟମ୍ ଯୁଗ, ଯେଉଁଠାରେ କ୍ୱାଣ୍ଟମ୍ ପଦାର୍ଥ ବିଜ୍ଞାନ ଆଧାରରେ ଉନ୍ନତ ଜ୍ଞାନ କୌଶଳର ବ୍ୟବହାର ହେଉଛି। ଆଚ୍ଛା, କ୍ୱାଣ୍ଟମ୍ କହିଲେ କ'ଣ? ସରଳ ଭାଷାରେ କହିବାକୁ ଗଲେ କ୍ୱାଣ୍ଟମ୍ ହେଉଛି ଯେକୌଣସି ପଦାର୍ଥ କିମ୍ବା ଶକ୍ତି ଭଳି ଜିନିଷର ସବୁଠାରୁ କ୍ଷୁଦ୍ରତମ ତଥା ଅବିଭାଜ୍ୟ ପ୍ୟାକେଟ୍ କିମ୍ବା ୟୁନିଟ୍। ବର୍ତ୍ତମାନ ଜାଣିବା କ୍ୱାଣ୍ଟମ୍ର ଇତିହାସ ସମ୍ପର୍କରେ। କ୍ୱାଣ୍ଟମ୍ର ଇତିହାସ କହେ ଯେ 14 ଡିସେମ୍ବର 1900 ମସିହାରେ ମ୍ୟାକ୍ସ ପ୍ଲାଙ୍କ ନାମକ ଜଣେ ବ୍ୟକ୍ତି ବ୍ଲାକ୍ ବଡି ବିକିରଣ ସମାଧାନରୁ କ୍ୱାଣ୍ଟମ୍ ତତ୍ତ୍ୱର ଧାରଣା ଏହି ବିଶ୍ୱକୁ ଦେଇଥିଲେ ଓ ପରେ ପରେ ଆଲବର୍ଟ ଆଇନଷ୍ଟାଇନ ଏବଂ ନିଲ୍ ବୋର୍ ମଧ୍ୟ ଏହାକୁ ଅଧ୍ୟୟନ କରିଥିଲେ। ବର୍ତ୍ତମାନ ଜାଣିବା କେତେକ ଅଜବ କ୍ୱାଣ୍ଟମ୍ ନିୟମ ଗୁଡ଼ିକ। ପ୍ରଥମେ ଦେଖିବା ତରଙ୍ଗ କଣିକା ବା ଦ୍ୱୈତ ପ୍ରକୃତି। ତରଙ୍ଗ କଣିକା ବା ଦ୍ୱୈତ ପ୍ରକୃତି ଦର୍ଶାଏ ଯେ ଗୋଟିଏ ପଦାର୍ଥ ଉଭୟ ତରଙ୍ଗ ପରି ଏବଂ କଣିକା ପରି ଗୁଣ ପ୍ରଦର୍ଶନ କରିଥାଏ। ଦ୍ୱିତୀୟରେ ଦେଖିବା ସୁପରପୋଜିସନ। ଗୋଟିଏ କଣିକା ଗୋଟିଏ ସମୟରେ ଏକାଧିକ ଅବସ୍ଥାରେ ବିଦ୍ୟମାନ ହୁଏ, ଏହାକୁ ହିଁ କଣିକାର ସୁପରପୋଜିସନ ବୋଲି କୁହାଯାଏ। ଆମେ କଳ୍ପନା କରିପାରିବା ବାୟୁରେ ଏକ ଘୂର୍ଣ୍ଣନ ମୁଦ୍ରାକୁ। ତୃତୀୟରେ ଦେଖିବା ଜଡ଼ତା ବା ଏଣ୍ଟାଙ୍ଗଲମେଣ୍ଟ। ଏଣ୍ଟାଙ୍ଗଲମେଣ୍ଟ ବା ଜଡ଼ତାର ଅର୍ଥ ହେଉଛି ଦୁଇଟି କଣିକା ବା ତତୋଧିକ କଣିକା ପରସ୍ପର ସହିତ ଏକ ଅଦୃଶ୍ୟ ଶକ୍ତିରେ ଜଡ଼ିତ ହୋଇ ରହିଥାନ୍ତି, ଯେଉଁଥିରେ ଗୋଟିଏ କଣିକାର ଅବସ୍ଥା ଅନ୍ୟଟିକୁ ପ୍ରଭାବିତ କରିଥାଏ। ଚତୁର୍ଥରେ ଦେଖିବା କ୍ୱାଣ୍ଟମ୍ ଟନେଲିଂ। କ୍ୱାଣ୍ଟମ୍ ଟନେଲିଂର ଅର୍ଥ ହେଉଛି ଗୋଟିଏ କଣିକା ସାଧାରଣତଃ ଯେଉଁ ପ୍ରତିରୋଧକୁ ଅତିକ୍ରମ କରିପାରେ ନାହିଁ ତାହା ଦେଇ ମଧ୍ୟ ଅତିକ୍ରମ କରିଯାଏ। ଏହାକୁ ହିଁ କ୍ୱାଣ୍ଟମ୍ ଟନେଲିଂ ବା ଭିତ୍ତି ଭିତରୁ କଣିକା ଯିବାକୁ କୁହାଯାଏ। ଶେଷରେ ଦେଖିବା ହାଇନିବର୍ଗ ଅନିଶ୍ଚିତତା। ଏହାର ଅର୍ଥ ହେଉଛି ଗୋଟିଏ କଣିକାର ଗତି ଏବଂ ସ୍ଥାନକୁ ଏକା ସହିତ ନିର୍ଣ୍ଣୟ କରିବା ସାଧାରଣତଃ ସମ୍ଭବ ନୁହେଁ, କାରଣ ଯଦି ଗତିକୁ ନିର୍ଣ୍ଣୟ କରିବାକୁ ଯିବା ତେବେ ସ୍ଥାନ ଅନିଶ୍ଚିତ ହୋଇଯିବ ଏବଂ ଯଦି ସ୍ଥାନକୁ ନିର୍ଣ୍ଣୟ କରିବାକୁ ଯିବା ତେବେ ଗତି ଅନିଶ୍ଚିତ ହୋଇଯିବ। ବର୍ତ୍ତମାନ ଦେଖିବା କେତେକ ସମ୍ଭାବନା ଗୁଡ଼ିକ ଯାହା ଆମ ବିଶ୍ୱକୁ ବଦଳିବାରେ ସହାୟକ ହେବ। ପ୍ରଥମେ ଦେଖିବା କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର। କ୍ୱାଣ୍ଟମ୍ କମ୍ପ୍ୟୁଟର ଆଜିଠାରୁ ସବୁଠାରୁ ଶକ୍ତିଶାଳୀ କମ୍ପ୍ୟୁଟର ଠାରୁ ମଧ୍ୟ ଲକ୍ଷ ଗୁଣ ଦ୍ରୁତତର। 2019ରେ ଗୁଗଲର ସାସାମର ପ୍ରୋସେସର ଗୋଟିଏ ଜଟିଳ ଗଣିତ ସମସ୍ୟାକୁ ମାତ୍ର 200 ସେକେଣ୍ଡ ମଧ୍ୟରେ ସମାଧାନ କରିଥିଲା, ଯାହା ଆମର ପାରମ୍ପରିକ କମ୍ପ୍ୟୁଟର ବା କ୍ଲାସିକାଲ କମ୍ପ୍ୟୁଟର 10,000 ବର୍ଷରୁ ମଧ୍ୟ ଅଧିକ ସମୟ ନେଇଥାନ୍ତା। ଏହା ଜଳବାୟୁର ମଡେଲିଂ ଏବଂ ଡ୍ରଗ୍ ଡିସ୍କଭରିରେ ମଧ୍ୟ ଅଧିକ ସହାୟକ ହୋଇପାରିବ। ଦ୍ୱିତୀୟରେ ଦେଖିବା ସୁରକ୍ଷିତ ଯୋଗାଯୋଗ। କ୍ୱାଣ୍ଟମ୍ କ୍ରିପ୍ଟୋଗ୍ରାଫି ଯେପରି QKD ତଥା କ୍ୱାଣ୍ଟମ୍ କି ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ ଏକ ଅଭେଦ୍ୟ ଡିଜିଟାଲ ସୁରକ୍ଷା ପ୍ରଦାନ କରେ, ଯାହାକି ଆମର ସୁରକ୍ଷାରେ ଅଧିକ ସହାୟକ ହୋଇପାରେ। 2025ରେ NIST ତଥା ନ୍ୟାସନାଲ ଇନଷ୍ଟିଚ୍ୟୁଟ୍ ଅଫ୍ ଷ୍ଟାଣ୍ଡାର୍ଡସ୍ ଆଣ୍ଡ ଟେକ୍ନୋଲୋଜି 2025 ସୁଦ୍ଧା ଏହାର ପ୍ରତିକାର ନିମନ୍ତେ ଏକ କ୍ୱାଣ୍ଟମ୍ ପ୍ରତିରୋଧୀ କ୍ରିପ୍ଟୋଗ୍ରାଫି ନିର୍ମାଣ ପାଇଁ ପ୍ରତିଶ୍ରୁତି ଦେଇଛି। ତୃତୀୟରେ ଦେଖିବା ଚିକିତ୍ସା ଓ ଗବେଷଣା। କ୍ୱାଣ୍ଟମ୍ ସିମୁଲେସନ ଜଟିଳ ଅଣୁଗୁଡ଼ିକର ବିଶ୍ଳେଷଣ କରି କର୍କଟ ଏବଂ ଆଲଜାଇମର୍ସ ପରି ରୋଗର ବିଶ୍ଳେଷଣ କରିପାରେ। ଏହା ଆମକୁ ଅତ୍ୟାଧୁନିକ ଚିକିତ୍ସା ପଦ୍ଧତିରେ सहायक करिपारे शेषे देखबा शक्ति और परिवेश स्टैनफोर्ड यूनिवर्सिटी अनुଯାयी 2025 सुधा एक कार्बन प्रतिरोध सृष्टि करिवो जहा 20% कार्बन रो निर्गमन ह्रास करिवो एहिपरि भाबरे जीपीएस सिस्टम सौर पैनल आलोक निर्वाही डायोड बा एलईडी आर्टिफिशियल इंटेलिजेंस रो अग्रगति एवं विज्ञान रो गवेषणा रे मध्य विप्लव आनि परिवो यह सब थिला क्वांटम रो आरंभ द्वारा कार्य गुडी को किपरि दक्ष एवं सरलतार सहित होई परिवो किंतु आपण माने जानती गोटी मुद्रा जहार दुईटी पार्श्व थाए दुईटी पार्श्व परस्पर सहित जड़ित होई रहतांती किंतु परस्पर ठारे संपूर्ण अलग होइथांती एहिपरि जदि हम क्वांटम रो संभावना गुडी को ग्रहण करिबा तेबे एहार प्रतिरोध को ग्रहण करिबा हम पक्षे अनिवार्य अटे प्रतिरोध कथा चिंता कले प्रथमे पाइबा जटिलता और खर्च क्वांटम पद्धति निर्माण अत्यंत जटिल और खर्चाळ गोटे क्वांटम कंप्यूटर निर्माण पाई अत्याधुनिक परीक्षागार और अति निम्न तापमात्रा यथा -273 डिग्री सेल्सियस बा एब्सोल्यूट जीरो आवश्यक द्वितीय रे देखबा नैतिकता और सुरक्षा क्वांटम कंप्यूटर आज सांकेतिक कोड गुडी को भांगी पारे जहा द्वारा हम डिजिटल सुरक्षा विपद रे पड़िबो NIST तथा नेशनल इंस्टीट्यूट ऑफ स्टैंडर्ड्स एंड टेक्नोलॉजी क्वांटम प्रतिरोधी क्रिप्टोग्राफी स्टैंडर्ड प्रस्तुत पाई प्रतिश्रुति देछि तृतीय रे देखबा शिक्षा और दक्षता क्वांटम विज्ञान रो दक्षता अर्जन पाई हमको युवा पीढ़ी को एवं हम शिक्षा अनुष्ठान गुडी को आह्वान रखबो कारण जदि क्वांटम प्रतिरोधी एवं कारण 2025 सुधा अनेक शीर्ष शिक्षा अनुष्ठान गुडी को क्वांटम को निजर पाठ्यक्रम रे अनुकरण करि सारिले किंतु एहाको विश्वव्यापी सुलभ करिबा एबे मध्ये हम पाखरे एक बृहत प्रश्न अछि शेषरे देखबा असमानता जदि क्वांटम पद्धति केवल धनी व्यक्ति धनी देश तथा धनी अनुष्ठान पाखरे रहे तेहा विश्वव्यापी असमानता सृष्टि करिवो तेणु UNESCO तथा यूनाइटेड नेशंस एजुकेशनल साइंस एंड कल्चरल ऑर्गेनाइजेशन अनुଯାयी एहाको विश्वव्यापी सुलभ करबा पई अंतर्जातीय स्तर रे एकता आवश्यक एक नवा जुगर प्रतिश्रुति एक क्वांटम जुग जोठारे असंभव संभव होबो किंतु एहा गोटिए जणर प्रस्तुति रे नहि एहा अंतर्जातीय स्तर रे समस्तकर एकता रे तेणु आसतु एक जुग गढ़ा एक क्वांटम जुग जोठारे समस्ते एकाठी मिसी कार्य करिबा जोठारे मानविकता समस्त हृदय थिबो एवं विज्ञान मनुष्यर पथ प्रदर्शक होबो एति कहि मोर उपस्थापन रे ध्यान देबी धन्यवाद
थैंक यू बहुत भलो कहला मुझे जानिया को चाहूची ए निम्न तापमात्रा कहीं की दरकार
कारण क्वांटम रे जो क्यूबिट थाए ताहा आम नेचुरल आम जो टेम्परेचर अछि ताहा सहय कर पारे ना हम जो नॉर्मल टेम्परेचर रे रहउछो ताहा सहय कर पारे आणि वो से एक्साइटेड हो जाय सेति में ताको निम्न तापमात्रा दरकार होय ना सर 0 केल्विन रो 0 केल्विन रो तले ले चलबो कि 0 केल्विन रो ऊपर को ले ता एक्साइटेड
0 केल्विन रो तळे
0 केल्विन लोएस्ट ना
अच्छा
कोड लास्ट केते
0 केल्विन
आता तळे
ताको सेते तापमात्रा रे गगन जति ताको अधिक तापमात्रा जवळ से एक्साइटेड हो प्रतिवाद अनुसार
एब्सोल्युटली नाही
किछटा चिप जो करा है जिससे
म्हणजे आला म्हणजे गोटे क्वेश्चन मध्ये क्वांटम के कोलो कोणी काय
क्वांटम ସବୁଠାରୁ କ୍ଷୁଦ୍ର ଯାହାକୁ ଆମେ ଭାଙ୍ଗି ପାରିବା ନାହିଁ ତାହା ଆମେ ଗୋଟେ ପ୍ୟାକେଟ ହିସାବରେ ରହିଥାଏ ତାକୁ ୟୁନିଟ୍ ବି କୁହାଯାଇ ପାରେ ତାହା ଗୋଟିଏ ଜାଗାରେ ସ୍ଥିର ହୋଇ ରହି ନାହିଁ ତାହା ଘୁରି ଯିବ ତାହା ଦ୍ୱୈତଗଣ ପ୍ରଦର୍ଶନ କରିଥାଏ ତରଙ୍ଗ ଏବଂ କଣିକାର ନିୟମ ଆମେ କହୁଛୁ
କଣିକା ଏବଂ ତରଙ୍ଗ ଦିଟା सबसे क्षुद्र कौन क्षुद्र कणिका कौन है क्वांटम ना
बहुत धन्यवाद
ଏଗୁଡ଼ିକ ତା ତୁଳନାରେ କ୍ୱାଣ୍ଟମ୍ କ'ଣ?
ତା ତୁଳନାରେ ମଧ୍ୟ କ୍ୱାଣ୍ଟମ୍ ଅତି କ୍ଷୁଦ୍ର
ଭାରି କ୍ଷୁଦ୍ର।
ଇଲେକ୍ଟ୍ରୋନରେ କ୍ୱାଣ୍ଟମ୍ ନା ନାହିଁ ହେଇପାରିବ ଇଲେକ୍ଟ୍ରୋନ୍ ଜାଣିଛ ତ ବହୁତ ମାନେ ତମେ ଯେଉଁ କହିଲ ପାର୍ଟିକଲ ଆଉ ଭେକ୍ଟର ତାର ଦୁଇଟା ଯାକ ଇଲେକ୍ଟ୍ରୋନରେ ଥାଏ ନା ଜାଣିବ
ସାଇନ୍ସ କେତେ ଜାଣିଛ କ୍ୱାଣ୍ଟମ୍?
ତମେ କ୍ୱାଣ୍ଟମ୍ କହୁଛ ସବୁ ମାନେ କ୍ୱାଣ୍ଟମ୍ ଷ୍ଟେଟ୍ ବୋଇଲେ ତ କେମିତି ଡିଫାଇନ୍ କରିବ କହିଲ? How to define a quantum state? ଜାଣିଛୁ ଆମ କୋଉ କ୍ଲାସ୍?
ଟେନ୍। ସେମିତି କହୁଛ ଯେ ବହୁତ ବ୍ୟୟବହୁଳ କ୍ୱାଣ୍ଟମ୍ କାହିଁକି ଆମେ ବ୍ୟବହାର କେମିତି?
କାରଣ କ୍ୱାଣ୍ଟମ୍ର ଫ୍ୟୁଚର ବେନିଫିଟ୍ସ ଅଛି ଯେପରି ଡିଫେନ୍ସରେ ଅଛି ହେଲ୍ଥ କେୟାରରେ ଇକୋନୋମିରେ ଅଛି
ଏକ୍ସାମ୍ପଲ୍ ଯୋଉଥିରେ ଆମେ ୟୁଜ୍ କରିବା କ୍ୱାଣ୍ଟମ୍
ଡିଫେନ୍ସରେ ୟୁଜ୍ କରିପାରିବା ସାର୍ ନୂଆ ନୂଆ ଅସ୍ତ୍ର ବାହାର କରିବାରେ ସହାୟକ କରିପାରିବ ଏବଂ ଏହା ଡ୍ରଗ୍ ଡିସ୍କଭରିରେ ମଧ୍ୟ ସହାୟକ ହୋଇପାରିବ
Thank you so much for the Mahapada participants. Let's move to the correct participant.
Good afternoon, everyone. Respected judges, respected teachers, and my fellow participants. I am Smritivida Sahu from Odisha Adarsh Vidyalaya Kirtija district, Cuttack. Today I am delighted to be a part of state-level science seminar on the topic Quantum Age Begins, Potentials and Challenges. Before diving deep into this topic, let us know what is a quantum. Quantum refers to the smallest unit of matter and energy that can exist independently. And quantum mechanics deals with the behavior of matter and energy. Then what do we mean by quantum age? Quantum age just refers to an era where the technologies follow the quantum mechanics and quantum laws. My friends, quantum age is not in the future or not in the present. It has already begun. With the father of quantum mechanics, Max Planck, who gave black body radiation in the 1900s, followed by Albert Einstein with photoelectric effect, which explains the particle behavior of light matter. Werner Heisenberg with his uncertainty principle, and Erwin Schrödinger with the Schrödinger equation. Today, in 2025, the quantum mechanics is thriving. Let me explain the Nobel Prize winners of 2025, John Clark, Michael Barrett, and John Martini, who took quantum mechanics into next level. They showed the macroscopic level of quantum tunneling. How magical is that? Quantum mechanics is very different from classical mechanics. It follows certain rules and laws which are not for macroscopic objects or not in the level of classical physics, like superposition, entanglement, tunneling, and wave particle duality. Let's come to the potential of quantum mechanics. First of all, in my opinion, the most important potential of quantum mechanics is healthcare and drug discovery. By using quantum computers, we can dive deeper into the molecules and atoms of biology. By molecular simulation, we can find out how the molecules of one drug reacts with the patient's body cells. Hence, we can produce more personalized treatment for the patient. Next, it is also used in diagnosis of cancer cells and many other diseases. It studies the genetics of the patient and produces a more personalized treatment. Next, improvements in agriculture. Just like in human body, it can also study the genomics of the plant, which helps us to get desirable characters of our crops, which will in turn improve our crop yield and take agriculture into next level. Next, cyber security and cryptography. I can explain it in two ways. QKD, quantum key distribution, which just protects us from the traditional hacking that is based on classical physics. Quantum keys are very difficult to copy, so the current day hackers cannot hack our devices if we use QKD. And the next one is PQC, post-quantum cryptography. This not only protects us from traditional hackers, but protects us from future quantum threats. Yes, my friends, the quantum machine is so advanced that it can hack our classical device, so we want protection for that too. Next, AI and machine learning. The collaboration of AI and quantum technology can be revolutionary. It can advance the AI into next level and it can shorten the time period of machine learning, as quantum physics can use to study real-time problems and decision making very efficient. Next, traffic optimization and smart cities. By using quantum computers, we can solve our daily life problems such that quantum computers can analyze large sets of data and provide us with efficient and best routes, and also can reduce our travel time. Next, weather forecasting and climate modeling. By using quantum computers, we can study the complex climatic factors and we can get weather forecasting in a revolutionizing level. By using quantum computers, we can get the most accurate prediction of weather. Next, advancements in defense. In defense, we may face many problems in communication by using our classical computers. If we use quantum computers, we can get a secure and very private mode of communication in defense line. We can track our soldiers even in GPS jammed areas. Also, we can use the quantum computer to produce more potential and more effective weapons. Last but not the least, financial modeling. As we know, quantum computers can process large sets of data and also help in optimization, so it can be very beneficial for financial modeling and optimization. After looking into the potential, there are also many challenges and limitations that we face today in acquiring quantum technology 100%. Some challenges of quantum computing are, in technical and scientific arena, the most major problem is qubit fragility. The major problem we face is qubit's fragility. The qubit would want a very low temperature and it is very fragile to environmental noise, which can make it unstable, and hence our quantum algorithms can ruin completely. If we see in social and ethical arena, we can see that quantum technology would create global disparities. The countries which have acquired advanced quantum technology would be at the top of the ladder and the other countries would be just dominated by them. Also, it suggests a cyber security risk, as quantum technology can hack into our classical computers very easily. Also, last but not the least, building quantum computers is very resource intensive and cost intensive. So it can be very expensive, and also we don't have the skills to execute it now.
Okay, very nice talk. Can you just elaborate on why it is inefficient in error correction? Because we are saying that it is very good in computation and it can solve problems, but why it is not efficient in correcting the error?
And here I have written error correction in reference to the quantum beacon. Because when the quantum becomes unstable, it causes many errors in our algorithm, and if we try to correct those errors, it is very technologically intensive and we don't have that technology.
Can you explain the students what decoherence is?
Yes. So in a quantum computer, qubit exists in a unison.
That means they are coherent. They have almost same frequency and work in unison. But due to slight environmental disturbance, they can have varied frequency. Hence, they become decoherent. Hence, they don't work together, and it causes instability in qubits performance.
Let's see difference between classical mechanics and quantum mechanics. What is the difference?
So first of all, classical mechanics, you follow the laws of classical physics and uses bits. But in quantum mechanics, we use quantum laws like wave-particle duality. But in classical physics, there is no wave-particle duality. One thing is just a wave or a particle. In quantum physics, we can say that there is uncertainty principle. We cannot determine the position and momentum of a body at the same time. But in classical physics, it has explained that we can determine it separately and very specifically.
Applications are what? Applications are
Terms of
the example here. So classical application and another quantum. That can be difficult to quantum.
I will talk about encryption keys. So classical computers cannot take very long time to break encryption.
They have not invented quantum mechanics, quantum computer.
Yes, they will not like experiment. So in classical computers, we can find it hard to in diagnosis of diseases. I can give you one example of quantum mechanics in medical field, PET scans, positron emitting tomography.
PET scan.
Yes. This is the molecular control quantum.
It is quantum mechanics is used. Classical कौन use होता है? अगर कौन classical use होता है?
Actually gives different examples where quantum technology can be used. So one of the important sectors is gold, which is agriculture sector. So how you will use the quantum technology in agriculture sector? Can you just simplify how to do it?
So, saying that we can get desirable crop like in a crop, we can get higher yield, shorter maturation duration, and we can build drought-resistant crops also by manipulating their genetics.
How will you manipulate that?
So we can, as we know, quantum mechanics can go into molecular level. So by molecular simulation, we can delete or add a gene into the DNA of the crop, and hence we can manipulate.
Okay, thank you so much. Next we have to the next participant. Participant. The participant and the judges are ready. So it's
Sir.
time for Balish.
Check.
करो हाँ करो. Music is ready. Very good. Let's move to the Baleswar participant. Countdown starts right now.
Good morning to all. Welcome to Quantum Age. I am Chiranjeev from Baleshwar Jilla School, going to present an exciting topic, that is Quantum Age begins, potentials and challenges. The United Nations declared 2025 as International Year of Quantum Science and Technology. Human civilization has developed from Stone Age where simple tools and fire were discovered, to the industrial and digital age which brought machines, electricity and global communication. Today we stand in quantum age where quantum science promises revolutionary advancement in computing, communication and sensing. Now a question strikes our mind that what is quantum? The term quantum was discovered by Max Planck around 1900. He told that energy is not continuous, rather comes in discrete packets called quanta. What is quantum age? The quantum age refers to the current era where quantum technologies move from theoretical concept to practical applications. It is based on the principles of quantum mechanics, the branch of physics that studies the behavior of matter energy at very small scales like atomic and subatomic particles. It also explains phenomena such as superposition, entanglement, wave-particle duality and quantum tunneling. Superposition means a particle can exist in many states at once. For example, a qubit can be 0 and 1 at the same time. Also in the Ramayana, Ravan's son Indrajit created a Mayajal, an image based on superpositions where multiple possibilities exist simultaneously. Quantum tunneling is a phenomenon in quantum physics where a particle passes through a barrier. Wave-particle duality means every particle like electron and photon behaves both like waves and particles. Entanglement means two particles stay connected to each other even they are far apart. Now let us discuss the hidden ability, the potential of quantum technology bit by bit. The key component of potential technology are quantum computing, quantum communication, quantum sensing and quantum materials. First, abilities and applications of quantum computing. Quantum computing has revolutionized computation by solving complex problems faster than classical computer. Drug discovery and material science. Discovery of new medicines, catalysts and advanced material has become possible due to quantum computing. Artificial intelligence and machine learning. AI enables better pattern recognition and optimization in large volume of data to save time, cost and resources. Cryptography and cybersecurity enables quantum safe cryptography for secure communication. Climate and energy solutions. Quantum computing helps design more efficient energy grids, solar cells and batteries. In case of healthcare and genomics, enhances predictive model for disease prevention by speeding up genome sequencing and personalized medicine. Then quantum communication. Unbreakable security. Quantum key distribution uses the laws of quantum mechanics to provide hack-proof communication. Banking and finance. Secure transfer of sensitive data like transaction, preventing fraud and cyber attacks. Satellite communication. Quantum satellite can transmit secure signal across continent. For example, China's missile satellite, government and defense, protects classified data, ensures secure diplomatic and military communications. In case of healthcare, protects medical research and patient data against cyber threat. Future internet enables a new kind of internet with ultra-secure global communication and distributed quantum computing. Collaboration in science, connecting quantum computers and labs worldwide for research and simulation securely. Then, quantum sensing, medical imagination and healthcare, which enables ultra-precise MRI to detect early detection, non-invasive diagnostics and robotics operations. Navigation and positioning, provides GPS-independent navigation for space missions, aircrafts and submarines. Geology and resource exploration, detecting underground minerals, oil, water and earthquake using quantum gravimeters. Defense and security, quantum radar for stealth detection, enhanced surveillance and threat monitoring. Environmental monitoring, tracking climate shifts, ocean currents and volcanic activity through precise field measurements. Fundamental science and space, high precision atomic clock, deep space navigation and tests of fundamental physics. Then quantum materials. Materials like superconductor, topological insulator, graphene, wave and quantum spin liquid hold the potential for transformative technology like tolerant quantum computers, energy efficient electronics and ultra sensitive sensors. India also made very significant advancement using quantum technology. In science and technology, National Quantum Mission launched in 2023 with 6,000 crore investment. In economy, India became 5th largest economy in the world. In space exploration, success of Chandrayaan 3 and Aditya L1. In global diplomacy and leadership, India's role in G20 presidency 2023. In spite of huge potentials of quantum age, countries across the globe are facing different challenges. First, technical complexity. Quantum informations are extremely fragile and easily disrupted by temperature, environmental noise and decoherence. Scalability. Building large-scale quantum computers is still experimental and costly. Human resource challenges. Lack of trained engineers, physicists and programmers. ethical and security concerns, quantum computers could break classical encryption, threatening data privacy, need for quantum safe encryption, economic and accessibility gap. The advancement of quantum technology favors only to wealthy nations and corporations because of its huge capital requirement. India also faces challenges in different sectors such as skilled manpower, infrastructure, funding, coordination, awareness and ecosystem development. At last, I would conclude that quantum age is the dawn of possibilities, where smallest particles, that is quantum, create biggest revolutions. Thank you.
Thank you. Very good presentation. I have two questions. First, in Chandrayaan and Aditya, what phenomena, which quantum phenomena we have used? That is the first question.
Entanglement. Particles.
Can you explain that how, which kind of quantum phenomena we have used in Chandrayaan and Aditya?
And firstly, entanglement, where the particles in Chandrayaan 3 and the computers in the labs stay connected to each other, even the Chandrayaan is in the space.
Which particle?
In the materials in Chandrayaan,
Materials.
which are used to make Chandrayaan.
चंद्रयान जो हमने छाड़ी थे चंद्रयान छाड़ी थे ना चंद्र कौन पे छाड़ी एम बुला बुली करके आसी हो कौन किसी बड़े स्टडी कर जो कौन जो से पार्टिकल्स जो मेटेरियल्स हो कि जहाँ जो स्टडी करिए सो सेक्टर हम गोटे किसी गोटे दौथवा जहाँ क्वांटम फेनोमेना एक्चुअली सेटा तैयारी हो आ सेठी जाई देखियो कौन
रबर
communicate think of how we are communicating Chandrayaan long distance na how we are communicating
through entanglement.
what is it
Entanglement means two particles stay connected, even they are far away. If you change one, the other one is changed.
Okay, I will ask a reverse question. Before Chandrayaan, whatever satellite we send, how do we communicate?
Same.
That means classical. What is classical communication?
Classical communication means
How do you communicate classically?
mobiles
Mobiles की केमती connection आसुची केमती हमें signal आसी
through satellites.
what type of signal is coming what signal is coming
Okay, my second question is that you have used quantum mechanics for better security. Can you explain how quantum mechanics helps us in having better security? In defense or security, how do we secure data or other things by quantum
Communication system.
in defense sector?
Firstly, the government and defense. If you come, India और रशिया कथा हो चुके हैं इला फ्रेंडली कंट्रीज जब तारा मतलब कन्वर्सेशन अन्य कौन से देशों सुन लेना तो इंडिया और रशिया के डिप्लोमेटिक कन्वर्सेशन का सर तो लीक ही जो क्वांटम टेक्नोलॉजी टेक्नोलॉजी मतलब कम्युनिकेशन का इसे एंटांगलमेंट भी
quantum using the smallest particle how smallest
सर
size
सबुठ क्षुद्र अणु परमाणु अपभ्रमण
size कम
यस सर परमाणु एकदम सबुठ छोटा पार्टिकल ऑफ मोल ताठ भी पेन फिजिकल
केते माने मेजरमेंट ऑफ सब्जेक्ट सेंटीमीटर ये करना कोई लोग
सर सही बेसिस से बात करें
क्वांटम खाली पार्टिकल आउ चीज
सर से तीटा तो पार्टिकल भी हुए
थैंक यू गोयल फॉर दिस गुड गोयल मेथड
किछिटा फेनोमेनन को वेव बुझी पालानी किछिटा फेनोमेनन को पार्टिकल बुझी पालानी
କିନ୍ତୁ ଏକ୍ସପ୍ଲେନ୍ କରିପାରିବ ଯେ କ୍ୱାଣ୍ଟମ୍ ମ୍ୟାଥ୍ ଡୁଆଲ୍ ନେଚର୍
विज्ञान
ନା ନା ଏକ୍ସପ୍ଲେନ୍ କରି ଦେଖିପାରିବ ଯେ କ୍ୱାଣ୍ଟମ୍ ମ୍ୟାଥ୍ ଡୁଆଲ୍ ନେଚର୍
कोई बार भी देखे तो कोई बार
ଏକ୍ସପ୍ଲେନ୍ କରିପାରିବ
ମାନେ ଗୋଟେ ଲାଇଟର ପାସ୍ ରେ ଯୋଉ ଛୋଟ ଅବଜେକ୍ଟ ରଖି ଦବା ଲାଇଟ ସ୍କैटर्ड हो जाए ଯାହାକି କୁହାଯାଏ କ୍ୱାଣ୍ଟମ୍ ଟା ୱେଭ୍ ପାର୍ଟିକଲ୍ସ ଟା ବଜାଏ ସେଟା ୱେଭ୍ ସେଇଠୁ ପାର୍ଟିକଲ୍
तुम्हें पूरा एग्जांपल दला क्वांटम मटेरियल्स रो चार पांच का मटेरियल्स वेरी गुड एग्जांपल्स ता बिच गुड देखले टोपोलॉजिकल इन्सुलेटर्स जानि जो कौन से
टोपोलॉजिकल इन्सुलेटर होता जेटा कि पूरे इलेक्ट्रिसिटी क्वांटम का इलेक्ट्रिसिटी क्वांटम टू का इन्सुलेटर करता है जाकि इंटरनल इलेक्ट्रिसिटी माने करिया पे जी मतलब ये है सर इंटरनल हम तो कोई बार इंटरनल से इलेक्ट्रिसिटी को से कंसर्व करे किंतु सडन इलेक्ट्रिसिटी कंडक्ट करे ना आउटर सरफेस पर
ठीक है से इंटीरियर जोड़ा बॉल करे से एक्चुअली इंसुलेटर रहता है आउटर सरफेस का तो सरफेस ऑफ दैट मटेरियल सोच कंडक्ट
Thank you so much. Next question, get ready.
Afternoon, everyone. I am Alisha Panda.
Okay, sorry for the interrupting countdown. So you can begin it right now.
Good afternoon, everyone. I am Alisha Panda of Odisha Adarsh Vidyalaya, Jharkhand, Bahar, from my branch. And today I stand before you in order to discuss about the topic, the quantum age begins, its potential and challenges. So today, as we are entering a new era called the quantum age, that is driven by the strange and fascinating principle of quantum physics. This era revolutionized how we calculate and compute things. So let's move forward. So the quantum technology is based on quantum mechanics, and in order to understand quantum mechanics better, you have to understand the wave-particle duality, which means a substance depending upon the circumstances shows as well as wave nature and particle nature. And there are many scientists who have contributed greatly in this field, like Max Planck, Albert Einstein, Heisenberg, and many more. So let's move forward and understand what makes the quantum technology so unique. First is exponential power. There is a rule in physics called superposition, under which a substance can occur when shrunk down to the size of an atom or even smaller. It can occur in multiple states. For example, something similar happens in quantum computing also, and it enables us to do multiple kinds of operations and calculation at once, hence increasing the efficiency and speed. Now, diverse application. There is no doubt these days the quantum technology is being used in diverse fields, from quantum computing to quantum networking, quantum sensing and whatnot. Now, the rapid advancement. For example, the IBM Osprey processor with 433 qubits shows the rapid development in the quantum hardware system. Another example is Google's 2019 quantum supremacy, in which Google stated that for certain kind of calculation, the normal conventional or traditional computers would take 10,000 years to solve it. But the same calculation could be solved within 200 seconds by the quantum computers. So now, let's talk about the advantages and potential of quantum technology. First, in climate and environment. Using quantum technology, we can measure the water level, we can do weather forecasting, and we can also measure the amount of air and water pollution, which is the growing major concern these days. Now, defense and security. By an unbreakable encryption with quantum key distribution has made the data transformation much more secure and unhackable. Then the advanced industry. In industrial sector also the quantum technology is being used rapidly. Then comes to the healthcare sector. Quantum technology helps us to do molecular interaction at the quantum scale, leading to new kind of personalized treatment and drug discoveries. Now, quantum technology not only has advantages, but also many disadvantages. For example, the current method of encryption like the RSA and ECC rely on mathematical calculations which are easily solvable by the future quantum computers. And also the quantum computers require a perfect temperature that is approximately near 15 millikelvins, and specialized equipment which is not at all easy and cost effective to manage. And because of this, the experts are warning us that we should be prepared in order to face the future threats that may be caused by the quantum computers, which may emerge within the next decade or max to max within the next 10 to 15 years. So let's move forward and see India. India and the quantum race. India is not at all far behind. Under the Indian quantum mission, India is investing heavily, that is approximately 6,003.65 crore according to Wikipedia, in order to develop the quantum technology and make it more advanced, which was started in 2023 and keeping a target to 2030 and 31. And also by building 4 thematic hubs across India. Now, as the quantum future has arrived and is arriving more and more, so we should be prepared to face it. So we can be prepared by ensuring these: quantum readiness assessment, collaborative ecosystem explore use cases, strategic investment, and competitive advantage in progress. At last, I would like to say that the quantum technology is not in science fiction anymore. It is happening today, and we students, as well as future generation, we must be prepared, filled with responsibility, curiosity, and innovation in order to face it. Thank you.
Thank you for presentation. Can you tell your friends why do you call electron and protons as the quantum particles, but not like a ball or any other object that we see over here?
Ma'am, because as scientists have explained that quantum means very small. It is like energy packets. It is very small particles or waves, we can say. Well, if we take any objects like the ball, as you said, or any object like the TV and the AC, these are made up of atoms which consist of electron, proton and the neutron in itself. So if we take that, it consists of millions and trillions of quantum particles. So therefore, we cannot say that any certain object like the ball as a quantum.
What is the transition point? Like at which size we can call as quantum and which size we call as classical particle?
And when we move down to the atomic level, like below the atomic level, the electron, proton and neutron could be called as quantum particles and the related nearby sizes.
Can we call an atom as quantum particle?
No ma'am, because it consists of electron, proton and neutron which are much smaller than it, and it's made up of, the atom is made up of them.
Hydrogen atom is very small. It consists of only one proton
Ma'am,
and one electron.
ma'am, but it is made up of one proton and one electron, ma'am, so it can be divided into 2 parts. I think we cannot consider it as much.
That's not correct. More. So the quantum mechanics and classical mechanics will have explained very well. What are these principles which differ from classical mechanics to quantum mechanics?
As much I know, the classical mechanics studies larger particles like the table, how it functions, out of what it is made up of. But the quantum mechanics studies microscopic particles. So this is
Then the principles. They are governed by some principles, right? What are these principles?
The
Which
quantum
distinguish
mechanics-
from the
The quantum mechanics is governed by wave particle duality, quantization, and so this is
no other. What is uncertainty principle? You already told uncertainty principle, superposition, all these things you told, right?
yes.
Is it the principle or not? This can happen in classical mechanics or not?
No, it happens in quantum mechanics.
Then why did you say that?
Can you tell us the Nobel Prize in Physics in 2025 is based on which principle?
It is based on quantum tunneling.
Which principle? Basic principle.
Just explain tunneling to your friends.
It is a principle of quantum mechanics which states that if when a particle does not have sufficient energy, then also it can cross physical barriers.
Because of what? Wave nature or particle nature?
So I think it is because of wave nature.
তুমি রুম ভিতরে quantum phenomena observe করছো?
Yes, electrical particles.
What are these?
So these are light particles as a
Very good. Very good.
And judges also ready? So your countdown start right now.
Good evening everybody, I am Osman Farah from Bhutan district. I am standing in front of you to represent quantum as begins as specialist potential and challenges. Now, let's move to our topic. First of all, what is quantum? Quantum refers to the smallest discrete units of energy, matter or other physical properties. Now, what is quantum mechanics? Quantum mechanics is a branch of physics that studies the behavior of matter and energy in an atomic and subatomic level. Now, quantum mechanics is discovered by Max Planck. So, Max Planck considered as a father of quantum physics. We already discussed about quantum and quantum mechanics. Now, we move to our main topic of the student session. What is quantum? Quantum marks a transformative field in technology powered by quantum mechanics, like new technologies like quantum computing, quantum communication and sensing are far emerging with these implications. Now, the potential of quantum physics. There are a lot of potential of quantum physics. I will focus on some major potential of quantum. First of all, quantum computing. Quantum makes of progress faster than a classical computer. We know classical computer plays a key role in our daily level. If we compare a quantum computer to a classical computer, we will get some following results. First of all, quantum computer calculates with qubits which can represent 0 and 1 at a certain time. But classical computer calculates with transistor which can represent 0 and 1. Another is quantum computer power increases exponentially in proportion to the number of qubits. And a classical computer power increases in 1:1 relationship with the number of the transistor. Now, quantum computers have higher levels. It needs to be kept in alternative. And classical computers at lower level, it can be operating any hour room temperature. Quantum computer well suited for tasks like optimizing power, data analysis, and simulation. In classical computer, most everywhere like web browsing, gaming is best handled by classical computer. Quantum computer can be applied in prediction of synthetic loop, drug discovery, climate modeling, and AI. It has a potential to revolutionize our data processing and simulation. Communication through quantum. As our digital world is growing, we need more safety and safe communication. In this case, quantum enables ultra-secure communication by the using of the QPAD, which is impossible for a hacker to hack our quantum computer. Next is resistance of immutable attack. It refers to a cyber attack when an unauthorized person interrupts private messages between two parties. We all know finance sector and defense sector are the backbones of the country. In this case, quantum plays a game changer role in our defense and finance sector. First of all, defense sector. Quantum energy data system. It detects aircraft, submarines and hidden targets which is invisible to a conventional radar. And finance sector. First of all, fraud detection. Quantum can prevent or detect cyber attacks or hackers. We already discussed about the two potential of quantum. Now let's discuss about quantum sensing. What is sensing? First of all, what is sensing? Sensing refers to a communication through sense. Quantum are extremely sensitive material. Quantum can be applied in navigation and geology. It can detect changes in gravity, magnetic fields and more. Medical imaging. Quantum can detect complex energies at an early stage. And navigation, quantum can create GPS independent system for aircraft and submarines. And geology, quantum can detect our mineral deposits. I already discussed about the potential of quantum. Let's discuss about the challenges of quantum. First of all, technical limitation, decoherence, and knowledge errors. Decoherence refers to in quantum computer, qubits long-range state. Then next is difficulty scaling of quantum system. In a quantum system, increase of qubit. In a quantum system, to increase a qubit we have reliability and performance is quite high. It is very cost effective. But to run a program in quantum mechanics doesn't need a lot of money. Software are trained for this much. There are few experts who can program and run quantum computer. Ethical and security comes of encryption. Quantum could break our previous secret codes, which is used in your bank details, password, and in today's security system. Quantum software development. Next is, what is the position of India in quantum race? India is actively participating in the global quantum race with growing research initiatives and a positive ecosystem of quantum startups. This presents a unique opportunity for India to dominate in critical sectors such as healthcare, agriculture, and cybersecurity. In conclusion, quantum has posed immense promise, but also brings complex challenges. Continued research, investment, and global cooperation are essential to harness its full potential.
Okay, thank you. Can you explain how quantum sensing is different than classical sensing and why it is better?
Because classical sensing depends on classical sensing cannot detect our stealth aircraft and stealth submarines, but quantum sensing can detect like hidden targets, stealth aircraft and stealth submarines, which is invisible to a conventional radar.
Why classical cannot do?
Because
you said something. India is doing a lot of investment for the quantum. What are these? Any details about what exactly the steps have been taken by India?
कर्नाटक Bengaluru Hesakota is a city where quantum city is building a project of 6,000.
What they have quantum city is everywhere. What they wanted to do,
to create awareness among the people of quantum.
Awareness means go and talk to the people.
To tell about what is quantum.
But any teacher can do also. Your teacher can do, quantum can do.
Not every people know about quantum. Not every people know about quantum.
All school if you cover that, if the teacher tells student that quantum does this, then that is not awareness. What extra engagement?
She is applying quantum views on apply quantum in our critical situation in critical sectors like agriculture.
India has to develop quantum device. Is anybody a device invented any device in India? You know where?
Dr. Rajendra
Where?
QPA Indus. The computer is QPA Indus.
Where it is?
India.
Where in India? Yes.
Karnataka.
No. So far nobody has developed a device except here.
Tata Institute.
Everybody doing it here.
So when you were talking about quantum sensing, what exactly you will sense there or detect there?
And navigation system.
Navigation. How it is different than the classical method. Navigation, you can use a compass. Okay. How it is different? Quantum sensing. Navigation.
Quantum will create GPS independent navigation. But a classical computer can create a GPS independent navigation system. GPS is a thing which global positioning system.
Can we talk why quantum is used?
To move an object to one place to another place, GPS is used.
You said quantum is very small.
Yes.
So how it will be used in global system?
So thank you so much. Thanks for bringing another first participant. That is our Kandhamar district. So participant, Kandhamar participant get ready. Judges are also ready. Their mic on. So the next participant is our Khurda.
Thoughts of debates first and wide. No place for to the esteemed judges, guide teachers and all my fellow participants present over here. I am the senior summer student of class 9 representing Odisha Vishwavidyalaya H. Kottapalli Jharsuguda and State Level Science Seminar 2025. Today, I'll speak about how the world works and the tiniest scale possible where waves are particles and particles are waves and the line between what is and what is not gets blurred. Yes, I'm talking about the quantum age that marks the dawn of the new age of science and technology. As the classical age gave us electricity and the digital age gave us computers and internet, the quantum age promises to revolutionize our world in ways we are just beginning to understand. So with this, let's explore the vast topic of quantum age begins, potential and challenges. Beginning with the introduction that says how quantum age refers to the era where we use the quantum mechanics to develop the quantum technology and reshape our computing, communication and sensing. Talking about the history of quantum age that began when Max Planck introduced the idea of energy quanta, which marked the birth of quantum mechanics or theory. Later, Albert Einstein, Niels Bohr and Werner Heisenberg developed this idea betterly and laid the foundation of quantum mechanics. Talking about the two major principles of quantum theory that says quantum entanglement and superposition theory. First, quantum entanglement that explains how two quantum particles are linked and they share a mysterious connection between each other regardless of their distance. Second, superposition theory that explains how quantum computers use qubits that can exist in multiple states simultaneously and show possibilities of both yes and no at the same time. And it promises exponential improvements in speed, security and problem solving. With this, let me just move towards the potential of quantum age. First, quantum computers that simulates the molecule at atomic level and shows impact like how classical computers take years to perform a task, but quantum computers solve the same task within some weeks. For example, IBM, modular accelerated vaccine and drug designing. Second, quantum safe cryptography. Here the term cryptography literally means encryption and decryption of data. That means our communication is secured and our sensitive data are protected from hackers. For example, source algorithm that can break through RSA's encryption. Third is optimization of problems. Like it can help in airline and delivery like route planning, fuel efficiency and package delivery. For example, companies like Goldman Sachs and JP Morgan. Fourth is finance that can help in risk analysis, fraud detection, fastest trading and decision making. For example, companies like Goldman Sachs and JP Morgan. Fifth is quantum computing that handles massive data set very efficiently. Sixth is quantum sensing that detects every minute change in gravity and magnetic fields. For example, Google Quantum AI that speeds up the ML model using qubits. 7 is quantum simulation that helps in climate modeling and weather forecasting and also says how NASA is planning for future space mission using quantum mechanics. For example, China's mission satellite that is the world's first ever quantum-based satellite. Now, we know that there is a code that explains how quantum technology or quantum mechanics is a like double-edged sword that can give extreme hardness as well as can accelerate the mankind like never before. So it also has some demerits. So let's discuss the challenges of quantum age. Beginning with the technical limitation. Living in the NISQ era, the noisy intermediate scale quantum era that is prone to errors and decoherence, building a stable scalable quantum computer is highly risky. Second, security risk. Quantum computers and all the data sets of today are kept in RC or ECCs that can be easily break down by the quantum computers and our financial and governmental data can be exposed. Third, high cost and accessibility. Quantum mechanics are highly expensive and they need a specialist environment to be used. Fourth, a lack of skilled workers. Quantum science is highly complex and it needs highly trained researchers, developers and engineers to be used. Fifth, ethical and policy challenges. The big question arises, who controls the quantum power? That means it has a high risk of misuse during the warfare and surveillance and can lead to monopolization one day. With this, let me just wrap up my presentation with a line that once Stephen Hawking said. He said, the age or the century of 21st century is a century of complexity and quantum theory is its heart. With this, let me just highlight India's initiative and achievements from launch of National Quantum Mission in 2023 with the approx budget of 6,000 crores and launching of 470 hubs, successful demonstration of free space quantum key distribution by ISRO and DRDO. Fourth, development of India's first ever quantum computer simulator by CTAC. Now moving towards the famous faces who won the Nobel Prize this year in physics 2025. John Clark, Michael H.G. Moran and John M. Martinez for the discovery of macroscopic quantum mechanical tunneling and energy quantization in the electric circuit. We know that from medicine, finance, cybersecurity, climate research, quantum technology is reshaping our world from every aspect. But it is also introducing some new risks like technical risk, ethical risk, geopolitical risk. But we know that it is also showing us or offering us things like unpredictable speed and capacities. But my important point says how collaboration, regulation and education are three important aspects we as a human must know before entering into the quantum age. Before going to my final thought, I'll say a quote by Richard Feynman who said, if you think you understand quantum mechanics, you don't understand quantum mechanics. It beautifully explains how vast and complex the quantum theory or quantum technology is, but it is also how interesting. With this to my final thought aspect that explains that quantum technology is not just the future of science, it is the future of our society. So we should and we will reshape it or use it wisely. Here I conclude. Thank you.
Thank you. So you gave so many examples. One thing is this year's So, what do you mean by quantum tunneling? What exactly is tunnel into? Energy
Sir, tunneling basically explains how in classical computers the bits needed some amount of energy to cross a barrier, a physical barrier. They needed some energy, but whereas qubits, they with a minimum amount of energy, they can still cross that same barrier regardless of them having the same energy or not.
Okay, that's fine. But which quantum particle? What I'm asking is getting tunneled and talking about tunneling.
It is the information that is being passed down from one qubit to the other qubit.
Okay, another interesting example you gave also from minute change in gravity. So can you say what the detection system or observation system is called, where we can actually observe or analyze the gravitational wave?
So we can, when we talk about the gravity or the magnetic changes in our solar system or our universe, we can take the example of China's Mystery satellite that is now working at for the area of 50,000 of
What is called that?
Sir?
What is called that? What's the name of that observatory? So, by using certain principles or certain techniques, we are able to analyze or we are able to observe the existence of that gravity or gravitational wave. So, what is called that? You can say it is experiment or experimental station. Do you know? Do you know that?
So we have multiples, like we have the International Space Station in the space. If we use quantum mechanism there, we can easily and in a very less time and very appropriately we can know the minute changes going on in the gravitational magnetic field.
So that is called actually LIGO, LIGO, laser induced gravitational observatory, where one can observe the existence of gravitational wave for the astronomical happenings. So from this actually, for that also we have Nobel Prize. So it's already Nobel Prize. Okay, thank you.
I could not attend, but I have certain things to ask. So, can you explain this free space quantum key distribution?
Ma'am, quantum key distribution is the QKD that helps in secure data transmission of quantum computers. When we know that we can also transmit the same data using the optical fibers, but using it in a free space can help us in reducing our reducing how much we spend in it, and it doesn't require anything specifically.
That is what we can do with it. Yes. But the question is, if to a common man you explain what is quantum key distribution, so how will you explain? What is this?
Now I would explain them saying in normal classical computers, when any data is transferred from one place to another place, it has a high risk of being transmitted misusedly or wrongly. But in when we use QKD, it helps us in changing
the advantage of that. But what it is, like through optical fiber, you can transmit. So that is an electromagnetic wave that gets transmitted through the optical fiber. But how it is different in quantum key distribution and what it is?
Ma'am, without using anything as a wire or anything, we can transmit the same data without anything. Like it may be vacuum in that sense there.
So how it is?
What is that?
How is it happening?
Final thoughts. And Herman said, if you think you understand quantum mechanics, you don't understand quantum mechanics.
So he has explained it that if someone who is trying to say that the person has already understand the entire quantum theory and already is known to the entire quantum mechanics, the person must not know anything about it, because it is such a vast and a complex topic, one cannot completely know about it.
Why it is vast?
Sir, it is vast because
you don't go on any rules? Or
it has some rules, but it is we are learning it in the atomic and subatomic level, the smallest scale
But then that
possible.
contradicts your final thoughts.
Sir?
That statement contradicts your final thought.
Yes, sir. It explains how it is vast, but it's still interesting, and we can't lay the future of our society in hands which we can't trust. That's what I said before in my challenges slide, that we need skilled workforce for it, so that when people are known to the quantum theory or quantum mechanism, they must handle the entire quantum system in the future.
According to what we mean by skilled person.
So a person must be knowledgeous enough to understand it and use it in a good way, in a good will way.
What do you mean by knowledge? What knowledge do you know?
So to me, one person must know about how it works, how it can be used, and what is it exactly.
I ask you,
Yes, sir.
what you have to know if you want to study quantum mechanics?
So to me, right now I'm in 9th. After my 10th, I'll surely go through I'll choose physics and maths for surely, and I'll try to crack JEE for that, and study at IITs to know more about my interest in quantum mechanics.
Why you did quantum IIT?
So because
It's a subject, right? What is your basic? You know the quantum mechanics.
So because in India right now, as much as I know, the 4 thematic hubs, one is IISc and other 3 are IITs only. So to my considering, I would choose that.
But you have to know the quantum mechanics, right?
Sir?
You have to know quantum mechanics.
Yes, sir.
That is what you need to learn, so you have to know quantum
Yes,
mechanics.
sir.
If you understand quantum mechanics well, then you can
Yes, sir.
devise or implement any device quantum mechanics.
Thank you for understanding.
of science with amazing powers but also big problems to solve. With this, I am Saskar Patnaik, obliged to stand in front of you with today's one of the most amazing topic, quantum which begins potentials and challenges. So let's start with redefining quantum ethics. Firstly, what is quantum? Quantum is about the smallest building blocks of nature and their strange behaviors. It is one of the 4 branches of physics. But quantum ethics means using the quantum technology in a way that benefits our society. With this, let's move forward for our first subtopic. The first subtopic is the dawn of the quantum age. In the dawn of the quantum age, science is unlocking new kinds of features by which we found that the universe is built on quantum rules. Some of the examples of quantum rules are quantizations, entanglement, superpositions, etc. From the classical physics of 19th century, we evolved the quantum mechanics of 20th century. And by using that quantum mechanics, now we are at quantum technologies. Like this is an example of classical physics, a pendulum. That is an example of quantum mechanics where light is behaving like both wave and particle. That is the example of quantum technologies. And these 4 are the branches of the physics. And at last, that is the picture of the father of the quantum mechanics, Max Planck. We are not entering into the digital future, we are leaping into the quantum future. Quantum is not just a science, it's a superpower. With this, let's start unlocking quantum potentials. Quantum computing. By using quantum mechanics, we can make computers millions of times faster than the normal computers, by which we can do a lot of things which cannot be imaginable. Then quantum communications. By using quantum mechanics, we can make communication more faster, more safer, and more in a way that we cannot imagine. Then quantum sensors. By using quantum mechanics in sensors, we can use sensors in finding a lot of things by which we can make our minerals and restore it. Also, we can use this kind of sensors in agricultural way, by which we can make agricultural sector more vast and more furious. We can use it like we can know which kind of crop can be grown in which kind of field. That would be advantageous things for us. Then quantum medicines and healthcare. By using quantum mechanics in medicines, we can make medicines more effective, by which we can treat a disease like cancers also. And we can also improve our healthcare facilities. Then economic growth and innovations. By using quantum computing, quantum communication, quantum sensors, quantum medicines and healthcare in economic sector, we can also grow our economic sector and the innovation sector. Then space exploration navigations. By using quantum sensors in spaceships, we do not need any kind of GPS systems, and by which we can go deep space explorations and navigations. Then national security and defense. By using quantum mechanics, ISRO and DRDO are making encrypted satellites and defense applications for the enhancements of national security and defense. We saw everything universally. Now we are going to see how India is going through this age. India's quantum leap. National Quantum Mission. India is investing in it for 8 years of 6,000 plus crore of money, and that is the logo of it. ISRO and DRDO are making quantum encrypted satellites and defense applications for the benefit of the India. Then IITs and IIScs are making global leaders in quantum research projects, and by which we know that the 2025 is known as the International Year of Quantum Science and Technology. Then India is acting as quantum innovation hub for the global south, by which India is helping the less developed country around us to grow with the help of India. Then the challenges ahead. High cost and infrastructure needs. As this kind of thing need to be stored in absolute 0 degrees Celsius, and for that it is very high cost related things. Because scaling the temperature at that level, it is very hard to do it. Then extreme technical complexity. As these kind of things use qubits rather than bits, and for that we have an extreme technical complexity. Then talent shortage. And lesser people are interested in these kinds of things, and for that we have a talent shortage in global stage. Slow commercializations. Having a lot of problems like high cost infrastructure needs, extreme technical complexity, and talent shortage, we have slow commercializations in market, because it will lead few years to launch this kind of product into the market, into the industries, or to the homes. Then ethical and geopolitical risks. Some countries are well developed and some countries are underdeveloped, and for that the gap between them would lead to ethical and geopolitical risks. Cyber security risk. Some country might show other countries information and data, and that would lead to intellectual piracy, and for that we have a cyber security risk. India's challenge. How India is having a challenge. India needs more collaborations, more investments, and more projects like MQM for it. Then the last section, the call to action of quantum future for all. We have to foster quantum education in schools and universities for better learning in early ages for students. Then we have to build global alliance for quantum ethical research, like already 7 countries together form a quantum research project which is known as G7 Quantum Actions. We have to build startups and innovations of ecosystems. By innovating our ecosystem, we can also innovate our sustainable development. And also, at last, I will conclude my seminar by saying a quote from Nelson Mandela that the greatest glory in living lies not in never falling, but in rising every time we fall.
That means if you take the challenges head on and make it into advantages, then we will enjoy a future which cannot be imaginable. Thank you everyone.
Very good, Sanskar. From the beginning, you have mentioned our universe based on quantum principles. Can you explain your trends?
Like universe is built on quantum principle. Firstly, some of the quantum principles are quantization, entanglement, superpositions, etc. Like firstly, I would like to say that entanglement. We know that in entanglement the particles, one particle is linked to another particle no matter the distance, and that is the definitions of entanglement. And by that we can observe in our universe also, or in our planet and etc.
Yeah, that you elaborate because they don't understand this entanglement. How do you realize the entanglement in our universe?
Like the use of entanglement, like India launched a spaceship which is known as Chandrayaan, and by that we found that from India, the space organizations, India's scientists are controlling the spaceships which is in the moon, and that is an example of entanglement. Like that, or superpositions can be used. Like already we are making quantum computers. Everything which is exist in this world is always exist in the universe. That I would like to see.
Very good. So what is the quantum action?
Sir?
Quantum action.
Action?
Quantum action. What is a quantum action?
Oh sir, here I have written that G7 quantum action where the 7 countries like USA, Japan, Canada, together together form a meeting where they talk about quantum related projects, and for that they given a name which is known as G7 quantum action. Sir.
Not in India?
No sir, India is not participated in it.
So what is the basic example you give? Then you tell that are classical and then you are using quantum. Give an example.
Basic example, sir. Like we can say we can use the black body radiation, sir. In black body radiations, the scientists who found that say that the energy always live in a continuous manner. But then the father of the quantum mechanics, Max Planck, used a theory which is known as quantum theory, and in it he says that the energy always live in small packets and discrete values, and that theory proves wrong to the classical mechanics, and that is the example, simple example of it.
What did he do that he observed this one? What we are doing so that he observed that particle should be this black body radiation should be packet wise. What is your objective? And what it is? The sequence.
So you told the Max Planck. Yes. Max Planck. What is that Max Planck radiation? So that will. Max Planck. Yes. How to define? What is the energy value?
So in black body radiation, anything which can absorb energy and emit radiations, and that thing would be known as black body. And when it is releasing energy, it always releases energy in a discrete value and a fixed amount of value.
Which is that? How to define?
Like I can define it, it will be like 5 or 10 or 15, not in a continuous manner, like 1, 2, 3, 4, not like that, sir. It always be 5, 10, 15 in a gap. Then there must be a gap between them.
So what I'm asking is that there is a particular energy measure, so you can Planck's describe it. So with Planck's constant, can you say that? Each equal to h mu.
Yes, sir. E equal to h mu. Sir, photons. So finding the formula of photon.
First of all, a very great afternoon to all of the respected judges and all of my enthusiastic audience. So, do you know that subatomic particles, like protons, electrons, and particles of light, photons, they don't actually behave like particles, they also behave like waves. This is weird, right? And now, can you imagine some kind of machine that that can solve problems in 5 seconds that would take much billions years in our classical supercomputers. Yep, with these weird facts, I may introduce you to quantum age, age of drastic change. So let us see what is quantum age. Humanity's progress is defined by technological shifts. Like first we were in Stone Age, we used stone tools, and then we went to industrial age, then to digital age. Now the current shift is the quantum age, a fundamental change in computing and problem solving capacity. Now this from the theory to technology, while quantum physics powered the first quantum revolution, transistors, lasers, MRIs, but the second quantum revolution focuses on controlling individual quantum systems to create new devices. You know, in quantum age, actually quantum mechanics started from early 20th century when classical physics failed to explain many types of concepts. But then a famous scientist named Max Planck came there to explain about black body radiation, and he said that energy of a particle is not smoothly distributed but distributed in discrete packets called quantum, which is actually the origin of the word quantum. Now, what is quantum technology? Built on quantum mechanics, the physics of very small, two core principles enable its powers: superposition and entanglement. There are many more principles like quantum tunneling and etc., but two more core principles power the quantum technology, which are superposition and entanglement. So the shift from classical binary logic to probabilistic multi-state logic. Now let us know about quantum bits, or the base of quantum technology. They are classical bits can only be 0 or 1. You know, classical bits are like switches. They can be on or off at one time. But quantum bits can be 0 or 1 or both simultaneously using the power of superposition. This parallel computation power dramatically increases the processing capability. Now, these are the pictures. So, key properties of qubits are superposition, existing in all possible states at once. A particle can also exist in all possible states at once, also a qubit. Then entanglement, two or more qubits become linked sharing the same fate, regardless of their distance. And then quantum interference. It is a a concept by which we can cancel out the wrong probabilities and find out the right probability of the correct answer. Now, let us talk about potentials of quantum age. Cryptography, breaking and creating complex encryptions, artificial intelligence, faster and more efficient machine learning, drug discovery, simulating molecules and chemical reactions, optimization, logistic, finance and resource allocation, climate modeling, complex large-scale simulations. Next, healthcare revolution. There are many kinds of revolutions there. Personalized medicine, designing drug tailored to an individual's genetic makeup. Then drug discovery speed, simulating molecular interaction far faster than classical computers, which just help us imagine medicines. Then molecular simulation, which is actually a best way to test our medicines. Accurate modeling proteins and chemical compounds to understand the diseases. Cybersecurity improvements, quantum cryptography, and quantum key distribution, a secure method for exchanging cryptographic key based on physics laws, not mathematical complexity as we use today. Next is, every revolution comes with some challenges. So this revolution also comes with some challenges, which are technical hurdles like decoherence, error noises, and scale. Quantum bits are very shy, and they are very sensitive to noise, temperature and sound. That is called decoherence. And now ethical and social concerns, job loss and automation, privacy risks, because quantum computers can hack many classical computers too. And then energy and resources constraint, cryogenic requirements, because quantum computers require 0 Kelvin temperature, which is minus 273.15 degrees Celsius. And to inform you, it is colder than outer space too. Next, security transition, post-quantum cryptography. So these are the challenges of quantum age, like energy resources challenges, cryogenic cooling. Most quantum computers require temperature near absolute 0 or millikelvins. High resource consumption, significant energy needed to run and maintain cooling systems. Job displacement, automation of complex tasks, while quantum AI privacy and security risks, the ability of quantum computers to break current public key cryptographies, and economic inequality or potential chasm between tech haves and have-nots in the quantum access. Next is my conclusion. So key conceptions are here, like we have potentials, but we also have challenges and we also have ethical risks. We also have potentials as to solve complex problems, double-edged sword, enable communication through quantum distribution. Significant challenges remain, progress is being made, but significant technical, economical and ethical hurdles exist too. Quantum computers will work alongside traditional systems to solve specific, extremely complex problems, not to use quantum computers to solve 1 plus 1. Now, I want to call you to an action, that is, we need proactive security measures, responsible innovation, and investment in education. Like government and companies must invest in the education and training of these things. And global collaboration is needed because no one country can use its resources to do quantum computing. So now, with this, I may conclude my speech that quantum age has just begun. It is as itself probabilistic. We cannot say if it will be successful or not, but if we try, we can bring it to the highest probability of being successful. Thank you.
Quantum technology, or quantum computer, somebody can hack your classical computer. At the same time, we can't think to protect our classical computers by using the any quantum module kind of things.
Actually, sir, I mentioned about it. We can use quantum cryptography and quantum key distribution to secure our data transmissions. That is a good way of securing our classical computers with it. But we have to see the both sides of the coin. It is possible to do good with this thing, but it is also possible to do bad with this thing. Like anyone can hack the classical computers and existing cryptography techniques. So it can also be possible for us to do it in a good way. Depends on the person who is using it. That is why I said that we have to do ethical consideration.
As a suggestion, don't use such a small font size in this kind of presentation. That doesn't give good visuals. Instead of so much text, you put more visuals and some keywords. That improves the presentation. Now coming to the questions, you mentioned about quantum interference, and just elaborate on quantum interference, and then how do you recognize a wrong probability or right probability? Just explain to your friends.
Okay, friends, in quantum mechanics, there is nothing deterministic. Everything is probabilistic. We use probabilities in quantum mechanics. So let us
first explain quantum interference and
yes,
how it is different than classical interference, then come to the probability.
Okay. So quantum interference uses quantum technology. I mean, it uses quantum technology to cancel out the wrong probabilities.
Yeah, so by which mechanism you do that?
I don't know.
Okay. Next is there is a challenge in scaling the quantum technology devices. So can you explain why it is so challenging? Why can't we scale it up?
Because I mentioned about many challenges.
Many challenges. I just want to know about the scaling challenges.
I don't get the question.
The question is why it is difficult to scale up.
I mean, look, quantum computers, which are the base of quantum technology.
Yes.
So we can't actually actually scale up them now because they require too much money and we don't have that much.
Is it only
No,
money?
ma'am.
Because there are many countries
yes.
who are ready to spend.
Yes, ma'am, but there is a loss in workforce. Not much workforce is there to do the work.
What a problem.
And also there must be technical experts who know about those things to work on them.
There are many experts.
But still we have ethical considerations too.
Not really.
Then I don't get any problem with this.
Okay, so you mentioned somewhere parallel computing. What is this quantum computing? Quantum helps parallel computing. Parallel computing can be done in classical, right? What this quantum computing help?
Parallel computing is not like beginning superposition to parallel computing.
Parallel computing can be done in classical.
How?
Can write the code.
That is parents, teachers and all my dear friends. Today I am stand over here to explain my view on the topic that quantum age begins potentials and challenges. Before we proceed to the topic quantum age is potential and challenges, first we have to know that what is quantum physics and what is quantum mechanics. Before we know that what is quantum age is that era where quantum physics is used with fully applications in our day-to-day everyday life. From this we can know that before quantum age, the world primarily operated within the framework of classical physics and Newtonian physics that deals with laws of motion, universal law of gravitation. It lasted from 18th to early 20th centuries. But that we know that what is quantum physics, that quantum physics is a broader field and quantum mechanics is a theory which comes under the field of quantum physics, and quantum mechanics is the one and only theory that explains how matter, energy and light behave at the atomic and subatomic level. Then there are many subdisciplines under quantum physics and quantum mechanics. The subdisciplines under quantum physics are quantum mechanics, quantum field theory, quantum optics. And the subdisciplines under quantum mechanics are superposition, quantum entanglement, wave particle duality, etc. Then we will know about that wave particle duality. In it, all matter and energy exhibit both wave and particle properties in atomic level. But classical physics treat is that which is a wave is not particle and which is a particle is not wave. But the quantum mechanics proves the classical physics wrong. And then we don't know that the electron beams get interference pattern, therefore it can be a wave. And here in photoelectric effect we know that the photons eject one electron, each electron, therefore eject photons as the particles and also can be a wave. Then the main topics of the quantum mechanics or quantum computing are superposition and entanglement. Superposition, we can understand it that how superposition occurs. That way, the quantum objects like electrons can behave as both particles and waves. This wave nature allows for superposition in electrons or in particles. That when the two waves intersect, they create an interference pattern. The second wave superimposed on the first wave, that is how superposition occurs. And second one is entanglement. What is entanglement? We all know that through the students are also tell that what is entanglement, but it can be understood through an example that if I have a left-handed glove, then I can say that other glove of the same pair is right-handed, no matter how far are they or no matter where are they. Similarly, that can be superimposed on the electron, that here is a electron and another electron is 50 light years far from it, but if there is small vibration in that electron, then there will be also a small vibration in other electron which is 50 light years far from this. Then we will understand that the potentialities of quantum age, that quantum computing, what is quantum computing? Through quantum computing, we know that it can calculate exponential way. 1 plus 1 equal to 2 plus 2 plus 2 to the power of 2 equal to 4. That is the power of quantum computing. Then quantum cosmology. Through quantum cosmology, we know that how space-time fabric emerges from the quantum mechanics, and quantum biology, we know about the quantum tunneling enzymes. From quantum internet, there is unhackable, unbreakable information traveling through a long distance. Quantum sensor, through quantum sensor, we can detect every minimal change in our Earth's magnetic field. Through quantum materials, you understand that superconductor materials like copper pairs are also used, which provide electric signals or electric current without any resistance. Healthcare facilities can be come into the subdiscipline of quantum biology, that they also help to make drug discovery. In industry, there is financial computation, financial modeling, problem solving, decision taking can be known through the quantum computer. And defense and security, through quantum key distribution, we can enhance our defense and security model. Education, quantum communication, finance, these all comes into the potentialities of quantum age. Then we know about the quantum tunneling. Then we know about the challenges to quantum age, which are cost inefficiency. High cost, immense cost is required to make a quantum computer, and it is not guaranteed that whether the working prototype will work or not. Qubit instability. Qubits are highly sensitive to environmental disturbances like temperature. Therefore, we need no vibration, no radiation, noise-proof, and safe and supercooling, that is absolute 0 minus 273 degree 1.5 Celsius, and limited scalability. There are millions or thousands of qubits to put in a system is out of practical. And error correction. The accuracy of quantum computer decreases with increasing number of qubits. Algorithm development. There are no such algorithms we can perform in the quantum computer. But there are algorithms, the language which is Python for classical computers and conventional computers, but they cannot be used properly in the quantum computers. Then there is limited infrastructure. Our infrastructure is too low, our edifices are too low, our apparatus, our machineries are too low that can manage the system of quantum computer. Then cyber security threat and data privacy. That cyber security, when there will be quantum division between the nations, the underdeveloped nations or the developing nations would suffer from the cyber security threat, and the users will lose their data privacy. Thank you.
Very good. You have spent so much energy. So you said quantum entanglement.
Yes, sir.
What I understand you say, if I have this hand, similarly other hand will be there. Left hand side something.
No, sir. If I have a left hand globe, then I can say that the other globe of the same pair is right-handed.
Right hand, same pair.
Yes, sir. Same pair.
Same pair. So like you, so same pair like you will be existing anywhere in the world.
Yes, sir. Same pair means there are, as you said, that there are 7 pairs or 7 types of peoples that looks like yourself. So, but in terms of quantum physics, the electrons, when one atom decay and forms 2 electrons, but due to a change, the electrons is here and another electron is so far from it.
What are these properties? Electrons are everywhere.
Yes, sir.
This electron, which property that can recognize other electron?
Entanglement property.
What is that?
Entanglement is that property which link the electron which is here, and what they, how they link. That they link from a state where they from their form. That when one atom decay, there are electrons, and one atom decay when they form 2 electrons. The 2 electrons shares a common state in one atom. Therefore, they can be in an entanglement position.
That will be everywhere. You know, that type of states, many states will be there. What property exactly matches with the other one?
What properties? First we got the superposition properties, then there can be entanglement.
Okay, partially correct, but not that. Okay. And second question I am asking, the topic is that quantum जो आरंभ संभावना what possibility you think future?
For quantum age, there are many potentialities that which
we are lacking now, which it can be solved better. Tell one example.
Yes, sir. And the mystery of universe. The mystery of universe that
mystery of universe.
Yes.
In quantum mechanics you can solve.
Yes, sir. We can solve through it. That
what type of mystery?
That types of mystery can be that we have not known that what is the proper definition for a relativity that changes our dimensions to quantum mechanics, and we can know through it that what will be the proper definition of the relativity, or we could know that how string theory, we can solve the mystery of string theory, that is there the strings are vibrating in one dimensional shape or there is particle which is
different issue. String theory is different issue. You said lot of
you said that how the quantum is potential.
Suppose I can say that how inverse created. Can you know that?
As that how it was created the Big Bang theory, but is the Big Bang theory is corrected in that universe is formed 13.8 billion years ago? That will be proved through the quantum computers and quantum age.
No, that is theoretical. How do you know experimentally?
Experimentally, that here is the light, and light travels in 3 to the power of 10 to the power of 8 meter per second. And when that light is reached to another dimensions of the universe, then the light takes time, and if we reach that another dimensions through entanglement, then we can know that when that light of that
Every question you have answer, but that is not correct.
Yeah. Okay. Can you differentiate between quantum sensor and classical sensor?
Yes, ma'am. Quantum sensors and classical sensors. In the frame of classical sensors, they don't have a, they cannot measure that each minimal change in the Earth's magnetic field because it is a type of field. But quantum, because it deals with.
Comment on your slides. Again, I hope audience will not be able to read the font size that you have used. So in future, you must take care of those things. Okay. Now coming to the questions, I just want to know, and I want you to explain your trends. How do you correlate finance with quantum technology?
As you can see that in the current, let us take for example a stock market. So we can see that there are certain patterns, but the current existing technology, through which the current existing technology, we cannot recognize the pattern because they are far too complex for our current capabilities. So what does quantum computer do? That it can see order in chaos because it has the high pattern recognition capacity, such that we can make more informed decision and invest our capital more intelligently.
I don't agree because what quantum mechanics is to be used there?
Its pattern recognition abilities.
That now we can also do at the beginning of mathematical.
Can be done with machine classical basis.
It can be done using classical technology, but it would be furthermore enhanced and efficient with the help of quantum.
What principle? Quantum mechanical principle.
Quantum, so the main we can use is superposition, its ability to exist both as 0 and 1, such that it would be able to do several calculations parallelly at the same time.
Now, we are taking the first computing time consuming less, but the result will be same. But what is future for quantum mechanics?
So the future for quantum mechanics would be mainly in the field of medical. For example, we would be able to stimulate drug production, and it would be able to how a certain molecule binds or reacts with viruses, for example. And next, and most importantly in the sector of communication, as we've seen that it is more and more becoming that people are using technologies to communicate with each other, and with this increases the risk of data piracy and identity theft. So to counter this, we can use quantum technologies such as post-quantum cryptography or quantum key distribution.
So what do you mean by quantum cryptography? People are telling that what is meant by quantum cryptography?
So quantum cryptography means we have to develop such methods that they cannot be hacked even using existing quantum technology. So as you can see that currently we use methods such as RSA and the EEC, which relies on complex mathematical problems that are complex for the existing computer capabilities, that is classical technology. But in quantum cryptography, what you can do, instead of using RSA and ECC, we can use lattice or hash problems which are difficult to solve even through quantum technology, such that our data is not at risk.
But cryptography is not in depth. Cryptography gets some control element. What is it?
So you use a very interesting terminology, which is control tunneling. Okay. So what do you mean by control tunneling and what?
We have to control like how it passes through the